is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's home. Boundaries set for sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Hey everybody, welcome to SkyTour live stream. It is me. Who's me? I'm Marc D'Antonio. Oh yes, I forget sometimes. And of course, as always, well not as always, but more often than not, we have Daryl here. Hello Daryl, how you doing?
Hello, Mark. I'm okay. How are you? Hello, everybody.
Doing fine. It's a beautiful night out there, and we are fighting a little bit of clouds, a few clouds. So we're hoping not to have to worry about them. So we're going to give it a shot, won't we? That's what we'll do. That's all I can say. We're going to give it a shot. So welcome, everybody. I'm glad to see you guys here. I'm just doing some final housekeeping. The image you see here on the screen, this is Aldebaran, the red star, the eye of the bull, and Taurus the bull.
Yep.
And you know what I want to do, Daryl? I want to look at the star tonight that is the one star that it's in orbit with a black hole that we can actually see. And that's GH is found trying to remember. It's a Gaia thing, but I'm gonna find that, and we're gonna look at that tonight. It's just a star, but we can't see the black hole, of course. But it should be interesting to see what of it we can see.
No.
It's just like I said, it's a star, but why not, right? Anything we can do to be cool, because we're cool.
I've seen a few mentions lately. One of the early guys, last name is Kerr, Kerr.
Okay.
He's saying that there is no such thing as a singularity in a black hole.
Yeah, I saw that. And if you remember what I said a few times, I've said that no scientists really believe that black holes have singularities in their center. And the whole point is that it's a giant chunk of mass. That's why it grows. If it was a singularity, it wouldn't grow when it absorbed mass, would it? Right? See, the logic is obvious. So clearly, these black holes that are these monsters, okay, they have grown because they have absorbed other mass. And I think that when you look at how much mass they've absorbed, clearly we would look at something, for instance, that's a monster black hole growing in size. Now, what's actually growing in size? And why would it grow in size if it was a tiny, infinitely small point in the middle? It wouldn't grow in size. It would stay a tiny, infinitely small point in the middle. But it does grow. So clearly, a black hole isn't a singularity. And that's something that is pretty obvious when you start to think about it, but not at all obvious to a cosmologist sometimes. So it makes sense to have these people come out from time to time and say black holes don't really have singularities. Now, his reason for saying that is a very different reason from what I've been talking about. What I talk about is a logic argument, and the fact that our physics dictated, and the way we use our physics dictated, that we created singularities at the center of objects. I've mentioned this before. We calculate the gravitational force between Earth and Moon. We calculate the force as if it's acting at the center, the very dead center of each object. Okay?
Sure.
So that dead center of each object is the equivalent of considering the black hole as having a singularity at its center. We're talking about the Schwarzschild radius. The radius of what? The radius from where? From the center of the black hole. So our math surrounds the need to have the center area, the central portion, being special in some way. And so that's why we have, equations like the force equals the gravitational constant g times the bigger mass times the smaller mass over the radius squared. The radius being measured from the center of each of these masses, or the distance between each of them from their centers. So that physics dictated that we look at a singularity, and then that's not why black holes were thought to have singularities. It's a whole different thing, and we can get into that too down the line. But the point being, it's really interesting to see how our physics is expanding and moving forward. And so black holes are indeed very interesting. I'm trying to find the name of that black hole, Daryl. It was a Gaia black hole. It's the closest black hole to the Earth, I think. I think that's what it is. So it's like GH51 or something like that.
You got me.
Okay.
Well,
I'll find it. Yeah, Gaia.
Singularity
BH1.
or no. I'm sorry.
It's in Taurus. That's where it is.
Oh. Singularity or not, at this point in time, I doubt we ever find out what's inside a black hole, though. What's inside the
I agree.
event horizon, that is.
Yeah. Space is so deeply curved that once the light starts crossing into there, it just circles around. Because light follows the curvature of space. It's not sucked in by gravity because it has no mass to be pulled by gravity. So let that sink in, those of you that don't understand how the universe works. the universe actually has a bendable fabric, effectively. And this bendable fabric is bent by gravity. And Earth creates this gravitational bend as well. We call these things gravity wells. The Earth's gravity well is a lot smaller than Jupiter's gravity well, which is a lot smaller than the Sun's. The Sun's gravity well is big enough to hold planets in orbit around it. Okay, but gravity is actually a very weak force, all right, which is interesting. It's a weak force that acts over a large distance. The strongest force in the universe is the strong force, but it works over a the smallest of distances. So the universe, in looking at it, it presents a lot of complications, a lot of contradictions, and a lot of logic bumps that make it kind of difficult to understand. But that's how it works, you know. So I think that it's very interesting when we talk about these things, and I want to. I want to find this black hole now. Let's look up BH1. I think it says, is it BH1? It might be.
Gaia BH1.
It is BH1. Okay. All right. Okay, so that's right in Taurus. I want to at least see the star that BH1 is associated with. Okay.
BH1 doesn't work. You might try Gaia BH1.
I did find it.
Okay.
17 hours, 28 minutes. And it's a sun-like star that's surrounding it. So let's see. That can't be right. Why does it say 17 hours, 28 minutes? And minus 0. Why they say Taurus? That's not Taurus. That's Ophiuchus. Okay, well, the article that I saw said Taurus, so we can't look at it tonight. It's not near here. It's back in our summer sky. So we'll check it out when summer rolls around.
What about the second closest black hole to Earth? Maybe it's in Taurus.
Maybe, but it was BH1 they talked about.
Yeah, well,
let's
second one is BH2. Marianne is here.
Marianne's here. Hey, Marianne.
Hi, Marianne. Hi, Izabela.
Isabella's here. I gotta say hi to everybody. Let me see. I wonder if it was BH2. Let's find out. It is. Okay, you're right. Okay, good. So let's actually, it's in the Hyades.
Yeah.
Mm-hmm. I just need
It's about twice as far away as BH1 is, but at least it's visible right now, so to speak.
It is. So
its companion is visible.
Yeah, I'm trying to find the coordinates. I'll have to go look it up in here. Let's do it right now. Gaia BH2. Oops, not BH at sign. BH2. All right, we're going to look this up and we'll find it. Here it is. Okay, so So am I out of my mind here? Okay, if we look here, okay, we're looking at Aldebaran. Okay, and the right ascension and declination of Aldebaran is 4 hours 37 minutes. And it says that Gaia BH2 is 13 hours 50 minutes. It's Centaurus. So this isn't right. Why are they saying that? Wow. No one gets this stuff straight. All right, well, you know what? Rather than waste time trying to figure that out, there are some things I would like to see. But first, I got to say hello to all the folks that decided to come on in. Hi, guys. Thanks for showing up tonight. Renee Cruz was first. Hi, Renee. Good to see you. And Alicia's here. Hi, Alicia Vieras. How are you? She says, the man, the myth, the Daryl. And my brother Daryl, my other brother Daryl. Okay. Tim F is here. Good to see you, man.
Dude, I never heard that one before.
I know, huh? PG, that's Petita. Okay. Papa Tom is with us. How you doing, Papa Tom? Izabela, Donald Kunzer, Daisy and Zoe Amethyst. Nice to see you as well. And I think that Shane D45, I don't remember if you've been here before, but you had to have been. Okay, Railroad Engineer, you have. I've seen you before. You're talking about the song at the beginning, Railroad Engineer? The song is The Universe is Calling You by Rebecca Borneman. And it's a beautiful song written. It's perfect for a SkyTour live stream. She wants us to use it as the lead song for SkyTour live stream, so we are. Really, really sweet lady and her husband, Dan. They're great people. And Lane is with us. Hey, Lane. Lane was with Daisy and Zoe tonight, I hope. Yeah. Because I see someone saying hi to Lane, so somebody must have said that Lane is here. And Bob is here. Where's Bob? Dagger Spells is here. Yep. And Rascally Rabbit's with us. C&D Boy. Man, we got some wonderful people here. You guys are all the regulars who make this all happen. Then we have Stuffy. What's up, man? Nice to see you. Eric Automotive. What's happening? Eric's Automotive Diagnostics and Repair. It's a heck of a channel and a heck of a name. Great to see you, man. Let's see. Pete Bodds. Nice to see you, man. We're going to be looking at some really cool things tonight. And then James Hyatt's with us. James, thank you so much. Let's see. Rockstar, nice to see you, man. Rockstar's with us. And here's the thing. If anyone has any questions, feel free to put them in chat. But put them in all caps, okay? Because I have a big curved screen here. I have observatory feed on the left, and I have broadcast feed on the right. So I'd like to be able to see everything that's coming in. I don't want to miss anything. So if you're going to ask a question, feel free, but just put it in caps so I can see it. That's the one time you're allowed to yell at me. You can yell in caps. I don't care. That's fine. Okay. Let's see here. All right. Calibos is with us. How you doing, Calibos? That's Mike. Marianne Robb is with us. Marianne is 1/3 of the Happy Triumvirate that makes up the SkyTour live stream organization. It's nice to see so many people here. I spent a lot of time putting this all together. And Genghis, good to see you, man. All right. So, Shane, are you someone I know by any chance? Shane D45? I'm going to guess that you are. All right, so let's go from here. Let's jump up to our planetarium view. Now let's just pop up to everybody's favorite cluster of the winter sky, the herald of winter to come, and that is the Pleiades star cluster right here. Okay, so we're going to head up there now. Okay, we're going to do some experimentation tonight. We're going to actually use a higher gain, higher sensitivity. There's our Pleiades. Okay. Izabela requested a higher sensitivity, so we're going to do that. We're going to go to 300 tonight, Izabela, because some of the objects we've looked at look a little different from last time. But we're going to do an experiment tonight and see how it looks. So let's do this. Let's get our telescope back. Let's center this up a little bit. Okay, there we go. The Pleiades, or the Seven Sisters, are interesting. You know the seven major sisters, right? And you can see them by just doing this and then counting the main stars, the brightest stars you see. That leads to 7 different sisters. You have Atlas and Pleione, Alcyone, Maya, Tegeta. I'm forgetting. Oh, darn it all. It's like a test, you know? So let's go see. I'll show you. And then we're going to look at what it looks like when you take a nice deep photograph of the area. Okay, so when you come in here, okay, Electra, that's the one. Electra Solano, there we are. Okay, yeah. And so, and Merope is right here. Merope has a beautiful nebula, which you're going to see here in a minute. So these are the main stars. Now, if you look at the Pleiades in the sky, you see the basic, it looks like a tiny little dipper, but it's not. It's just a collection of stars in a cluster, and it's in 3D. Hey, Dave Altman's with us. How you doing? Yeah, I know you called me, Dave. I couldn't answer because I was in the middle of the stream. I'm sorry. Dave is really cool. Dave is a wonderful guy out in California, producer, and so forth. There's a lot of really cool credits to his name. Nice to see you, Dave. A true celebrity in our midst. And so when we look at the Pleiades, you have to keep in mind that the universe is in 3D and everything is moving in the universe. So when we look at the Pleiades, we see not just these stars, but we recognize through analysis that there's over 1,000 stars in this group of stars that we see here.
Yep.
And they're all moving together through space, all formed kind of in the same place and then slowly spreading apart over time. And as they move through space, one thing that's happening is they're passing through dust in our galaxy, dust from countless past supernovae, all right, and countless past red supergiants that have sloughed off their layers to make this dust. And so this is something that they're passing through right now. When you look at them, you'd be tempted to think that this dust is something that they were formed in, and it's not. It's not at all. It's actually simply just dust that happens to be in space they're traveling through. In fact, the dust is going one way and they're going another. Pretty interesting.
When you look at the Pleiades up in the sky, if you have a reasonably dark sky, you look directly at them, you'll see the little dipper shape Marc described. You can see it there too. The handle of the little dipper's on the left there. If you avert your vision, you move your eye to the side, all of a sudden you'll see a big hazy patch of light instead of just 6 or 7 stars. And that patch of light's about the size of a postage stamp held in your fingertip at arm's length. And that hazy patch of light is all 1,000 stars plus the dust they're in.
And the dust they're in is what we're about to show them.
Yeah.
So we're going to start that. We're actually going to go... you can finish your thought, Daryl. Sorry, I didn't mean to cut you off.
No worries.
So we're going to live stack this image, okay? So, and we're doing 45 seconds at 300. So in our telescope, what's important to understand is some of what you're looking at when you look around. Okay, so for instance, let's look here. Okay, the most important field in here is the exposure right there. The second most important is the gain. Okay, the gain is how sensitive the sensor is, and the exposure is how long you're going to let light hit that sensitive sensor. Okay, over here, this is our telescope control system. That's our telescope computer. That's our telescope. That's several views of the same telescope right there. Okay. This is our stacking screen. This controls, I know all these arrows. This controls a whole bunch of things. Okay. It controls, like when we take a picture, right? And then we take a second picture, stack it on top of the first, and align the stars, and then just keep making image sandwiches. That's what this screen's about. And then over here, this is the telescope control, the camera control cluster. So that's lots of arrows, and I'll get rid of those. All right, but one of the things that's interesting, and we're waiting for the first one to come in now, is, all right, see, we took a photo, and although we're guiding on this right now, we have not met our full width half maximum guiding limitations. So what that means is the stars are elongating enough because of wind and so forth. And so when we see this, we see that that's a problem with the guiding, not the guiding, but the wind. There's a little wind. As soon as the sun sets out there, it gets a little windy. And we can't expect some wind out there. It's the desert cooling winds. And so what we can do is shorten the exposure. Let's go to 30 seconds, and maybe that'll give us a better result. And we'll clear this and start again.
I can't quite read what your telescope display says.
Yeah, I know. I'm trying to figure out. It's guiding right now, so it's showing us this the guider. Might be able to work with that. Let's play with this guy and see if that gives us any relief. Maybe, maybe not. Let's find out. Maybe that. That's brightness. Well, we'll get it. It'll work. We'll figure it out. Okay, so we're trying to catch an image here. Telescope is like a flag sticking up, so we're getting some wind. But sooner or later, we'll catch a good one. Let's bring this up so that we are here. I can actually just raise it above that threshold. So 1 second here. Daisy and the Cowboy. Hey man, how you doing? Shane, thanks for that explanation. Shane says that used to catch our live streams a lot. That might be where you remember me from. Yeah, I probably did. Okay, so here we go with that. So now we have our first image in here. Let's process it a little bit and get it to show. There we go. Let's get rid of this right here to show it a little better. There we go. Okay, so now what you're seeing is this dust all around the stars that Daryl was just talking about. I'm going to do a color noise removal here, so it's going to sharpen. There we go. It looks better right away. Okay, so it gives us an immediately better image. So this is Merope, okay, and this is that beautiful nebula that Merope is illuminating for us. Alcyone has its own, okay. Then we have Atlas and Pleione here. This is Electra over here. Maya, you can see the Maya Nebula is well known. It's that little finger of dust right here. Interesting how that looks. Now, so that's pretty cool. Hi, Fantasy. That's correct, Fantasy. This is the Subaru logo, if you've ever seen it.
It means union.
Yeah, unity. Yes, exactly. Unity,
unity.
union. Yeah, it's one of the two. I'm not quite sure which word in Japanese it means. I know that I've heard both, so who knows? Yep. All right. So let's. Eric says, Marc, in 2029, will Apophis be close and bright enough to resolve with your telescope? Oh, yes. We'll see Apophis in 2029 for sure. But we don't have to wait till then. I'm sure we could take some deep photographs and catch it. I was on Night Dreams Talk Radio the other night, and we talked about Apophis and so forth, and how the orbital elements, that is the orbit of Apophis, are now rather well known. So we know that Apophis will be, and this is true now, no threat to the Earth. Okay?
You're no fun.
I'm no fun. Yeah, that's right. Yeah, right. Don't look up.
You may get a better view than you ever thought.
Ha ha.
Maybe the last thing you ever see.
Don't look up. Yeah, no. But Apophis is actually pretty well resolved in its orbital elements, so we know that it's actually not going to be a danger to us. Here, let's bring that out of the way so we can actually catch this. Look at that. Look at the nebula here. This is beautiful. Right? We got these guys, all this stuff. So again, this is a cloud of dust that this bunch of stars, all 1,000 of them, are moving through. The dust, the way we know this is the dust is moving one direction and the stars are moving another. So we know they're not tied to each other. You know, this is cool. Now that blue dust, this is stuff that's only a few microns across. And the beauty of this dust is that it scatters only the blue light from the stars. It lets all the other light go. These stars don't just have blue light. Okay? They have a full spectrum. They have some red, orange, yellow, and some green, blue, indigo, and violet light. There's the Goblin. Here he is. Goblin, we need your information because you won the binoculars, man. I'm glad you're here. So if you go to skytourlive.org, right up here, right? Just do that. Go up here, right there, skytourlive.org, and email us in the contact form. Email us your information so we can send you the binoculars you won. You won a great pair of Celestron binoculars, man. And we want to get into you. All right? So I'm really glad you're here. Sorry to sidetrack you guys, but we had to. And if you don't know this by now, if you haven't been here, we do run contests for equipment. We already gave away a Celestron telescope. We gave away a pair of binoculars. We gave away another pair of binoculars. And that giveaway is courtesy of Calabos and Tiffany, who are in our chat. Calabos is a great friend to SkyTour Livestream and to me and to Marianne and Tara. And he's also an official volunteer along with his cohort in this wonderful exercise, Tiffany. So they're very much people that believe in trying to bring astronomy to the masses. And they recognize that's what we're trying to do. And so they're trying to help everybody. So they're helping us help you. All right, so Goblin, make sure you do that. Okay, we want to get you your stuff. So it's good to see you. We were wondering if you were coming in. So this is now, we're running this at 300 sensitivity here. That's really high. This camera is best suited for 150, okay? But we're running it way higher, more than twice as much. And we're doing that because we have the ways to reduce the noise. As you can see, this doesn't look noisy, right? Now, yes, there's noise. If we zoom in, you'll see the noise, okay, in terms of the pixels. Not that bad, actually. Yeah, you can just see a little bit of it. But look at all this detail. We can see all this beautiful detail in here. Yeah. And, of course, many of the stars that are part of the 1,000 stars in the Pleiades cluster that are all transiting this dust. I don't know, Daryl. This nebula right here, the Maya Nebula especially, it actually looks like it's almost overshadowing the brightness of the star itself in some ways. You know, that's kind of cool. So we'll leave it on 300 for tonight to see what we get out of this. And that 300 setting is a request of Izabela.
I dare say it may depend on what object you're looking at, how bright or dim it is.
Well, it certainly will. Certainly will.
Looks nice for now, though.
Yes, it looks really nice. All right, we have stacked 14 here. We're going to go to 15. And remember, we're right at the upper limit here. So we have some wind, but we're right inside the ability at this latitude to have a full width half maximum. That is the diameter of the star image to be within the limitations required to keep it nice and steady and small. Okay, let's mark this. We're going to change the name up here to the Pleiades. Okay. And then we're going to save it. Okay.
Before you head out
Sure.
to another object, can you go back to Stellarium for a moment?
Sure.
I just wanted to say something real quick.
Sure. So here we are.
Okay, can you back out to like our earlier view?
Yep.
Or the Aldebaran and the Pleiades are at the bottom?
Yeah.
When you look up in the sky in the direction of Taurus, if you can find Jupiter, look to the left or east of Jupiter, and you'll see the Pleiades there. And just below that is that V shape of the Pleiades, which makes the head of the bull.
That's right.
Aldebaran there is the eye of the bull, as Marc said, and his horns continue to the left off the field of view in Stellarium. When we look at the Pleiades there, that V shape, that is the closest star cluster to Earth, about 170 light years away. And then when you look up a little higher, you'll see the Pleiades, and it's another star cluster, obviously, and it's about 400 light years away.
Still close.
Yes.
By measures, yeah.
And when you look at Aldebaran, it's a very red star with the eye of the bull. Aldebaran is actually a foreground object. It doesn't belong in the Pleiades. So I guess you'd say it's a member of, just in the sky. It looks like it is. So Aldebaran is about 70 light years away. So if you can take in that view, you'll see Aldebaran is close. The Pleiades are a little more than twice as far away, and the Pleiades are about twice again as far away.
Yep.
And that could give you kind of a three-dimensional feel for what you're looking at up in the sky.
Very nice. That's an excellent way to put it. Very good. See? If you're not careful, you'll learn something.
Oh.
All right, so this is a beautiful image of the Pleiades. Really rich, very nice and rich with all this dust. So we're going to save it again, just like this, with 21 frames. Why do we save all these frames? Because when you take a picture, the area in the picture, you'll have data like a star or a nebula, right? But you're also going to get noise on the sensor. Now our sensor, as you can probably barely see right here, is running at minus 20 degrees Celsius. I've got it running very cooled. It's a super cooled sensor. All right. And this cooling process allows us to see images like this without a lot of noise. So it's quite a good setup. All right. And you can see right here, I mean, the telescope right over my head here. And so now this particular cluster, the 400-mile distance of the Pleiades, is immersed in this dust cloud. Now, the Pleiades, notice I remember I said Pleiades are still relatively close to us. Well, what's fascinating is, I've talked about this before, when we look at dust clouds in space and we say, what would we see if we were inside one? We wouldn't notice that we were. Well, guess what? It might be, and there's a research paper with other researchers suggesting the same thing, our sun and solar system and Alpha Centauri and a couple other nearby stars are actually in this dust that the Pleiades are in. And this Pleiadian dust cloud extends all the way to us. And it's in our galaxy, part of the spiral arm that we're in, or the section of the spiral arm. And it's an extension of it, and we're all moving together through it. So we wouldn't notice it from inside of it. And certainly if you were here, you wouldn't notice it either. So it's pretty interesting. You might be a family member of the Pleiades, in other words. Just in terms of, dust. And I've said this before, the dust is really where it's at. Its life began in the dark. I've said that before. Thank you, Izabela. Thank you very much for putting that link up. All right, so let's redock our line here. We're getting good results here. Let's see what it wants to do for processing. Yeah, it's probably going to pull it back just a little bit. Yeah, and we're good. Let's see if we can color correct if we're going to get any differences. All right, we're good. And that's 26 images. We'll save that one more time. Now, when I see I'm saving it, you see the green bar across the top. These images, one is a FITS file. That's a astronomical file format that we work with as astronomers. I'm an astronomer. This is what we look like. And then I have a ping file that I'm saving, which I just saved. And there it is. And if I click on that, okay, this is what's saved. This exact image you see here is saved up there. So you'll be able to go in and say, wow, I want to check out that dust. You could zoom in on it and check it out and put that on your desktop as a background. You can do anything you want. Because up at skytourlive.org, right here, okay, up at skytourlive.org, you will find right below the main panel at the top is the next one that says, I want to see cool pictures. And you'll read the instructions there, and it will take you to the database server or our server where you can actually get at all these pictures we took tonight and then see all the ones we've taken for over a year. So you can spend a lot of time up there looking through photos, and they're all named so you know what they are. Okay, good. So I'm glad we got that out of the way, class. So let's redock this, put that in, all right, and let's come out of here because we're done with this particular object. But interesting how when you just take a little bit of an extended shot, a little extra time in a way that your eye can't, your eye doesn't accumulate light. Your eye just sees instantaneous pictures like this one we're seeing right now. Okay, the light comes in and then it's gone. It doesn't add up. But when you add up light, that's when you see things like a amazing nebula that's hiding in the background. But there are some nebulae you can see, By the way, I think before we do the Boogeyman Darrow, we should probably do the Witch's Head Nebula. Because the Boogeyman probably won't be up enough, but Witch's Head will.
Oh, it's early yet.
Yeah. So let's
go.
go.
Orion transits before 11 now, so you got several hours yet.
That's 1 a.m. for me.
Well,
I'm in Connecticut. The telescope's in Arizona, and I'm running it from Connecticut. So that's, yeah. Ryan's here. Okay. Now these are our zenith coordinates, azimuthal coordinates are called, and these are our equatorial coordinates. So the North Pole is up that way in the image up here, right? So if we look at how high Orion is above the horizon now, you'll see that if I bring up the zenithal coordinates, that Orion right now is only about it's 40 degrees above the horizon to the belt stars. We might be able to see stuff there, okay? But we might also be able to see Rigel, and Rigel here, okay, is right here. Rigel, it's partially in it being blocked by our observatory walls, okay, because anything to the east, which is where we're looking here, it goes up like this and over the top and then down, okay. When Orion is straight up and down in the sky, it's going to be pretty much directly south of us. So as you can see, it's leaning over because it's still toward the east. But when it gets a little higher, we'll be able to do more with it. So while we're waiting for that to come up, I figured we'll look at some other things. So we looked at the Pleiades, and we looked at that amazing structure up there. And I thought maybe if we come around here, we go, let's see, well, we've been in Auriga quite a bit. Let's see if we can do here. Let's see now, the California Nebula is down in Perseus here. We should be able to see that, you know. Yeah, we can find it. There's the 37 cluster. Christmas tree isn't quite high enough yet. So let me do this. Let's do that. Okay, so that's going to be almost directly overhead. So that's really worth looking at. So this is another nebula. Well, we saw a reflection nebula, which is just dust that is reflecting the light of the blue light of the stars, and only the blue light of those stars in that cluster. What we haven't seen yet is a emission nebula, a nebula that is actually emitting light because it has hydrogen gas that's being ionized. And that's something that I'd like to show you now. Now you can see a little bit of it right here, but not a whole lot yet because we're still in our this mode here. We're just like a finder mode. So let me just move us a little to the west a little bit. I'll do this. And then bring that down a little bit. Just to catch a chunk of this. There we go. And the star that's lighting it up is this guy right here. And I'll show you that here on Stellarium. Alright, so we come in here. And go here. Alright, this is our telescope. Now you'll notice that this is kind of on its side. This is our field of view. Okay, it's 1.5 degrees by 1 degree in size. So you have to turn your head to the left to see where, but we're right, not quite there. We're actually, we're right here. So we're just a little bit off on this, but that's good. So what I'm going to do is I'm going to head to the upper right a little bit and show you the rest of this beautiful emission nebula. So there's Menkib down below, and that's powering this nebula. All right, and then we'll just come over here and move over a little. Okay. This I think will show us these beautiful arcs. Okay, and again we're going to try doing a 35-second exposure here. And if you want to know how long that's going to take, I'm just turning off our finder mode. You can see right over here, all right, there's our counter, counts down. All right, and now we're also going to live stack. Now the previous stack should be visible in here. And it is, it's the Pleiades. So we'll clear that now. And you wonder where it's going. As we save these, as I've been saving them, you saw the blue or the green lines. They're actually heading on out and leaving the observatory from deep in the Arizona desert, going up to the satellite and coming down to our server, where they're made available to you within 35 to 45 seconds. Look at that. That is the California Nebula, and that's a beautiful region of the California Nebula. Let's develop this for a bit. This is an emission nebula. An emission nebula because the hydrogen atoms in here are ionized. The electrons are popped off the atom because they're absorbing a lot of that ultraviolet energy coming from Menkib, the star that's down here. That star was just out of the field down here. We talked about it. Okay, and I just got it out of the way just so we can see these. And this is a piece of dark nebula in here. And all this stuff, all this is hydrogen gas that's actually emitting light. And the reason it's emitting light is because those electrons absorb energy and bounce off the atom. That's called ionization. And now you just have a positively charged proton, because hydrogen's a proton and electron. The electron leaves the atom, leaving the proton all alone for a period of time. The electron then, while it's bouncing around out there into other objects, it comes back into the atom, and as it falls back into the atom, it gives away that energy that it had. And as that energy is bled off, it comes off in the form of light. And that light, in the case of the hydrogen atom, among other colors, is predominantly red, like we see right here. Okay, so that's why we see this as we see it, right? So this is the color of ionized hydrogen that we see here. Yeah, we got this dark patch here. We got this dark patch here. Beautiful tendrils in here. Let's go into our stack here and just process enough just to. Here we go. Look at that. Let's color correct as well. It's gonna remove a little of the red. Okay. I don't like that color correction. It's not correct for me, but I want to show you the nuances in here. Look at all these details in here. There's a lot of stuff in here that we couldn't see with the last telescope, the camera, I mean. Yeah, that's too much there. Let's bring this here. And let's kick this down. There we go. Let me just do this. All right, I'm just gonna do some adjustments here. All right.
It's Northern California on the upper right, if you hadn't figured it out yet. And that's Pacific Coast across the top left,
yep.
Down to the lower left. And I guess where that crook is that Monterey?
Here?
No, the
or
crook.
here.
Right there.
Yeah, this is, San Francisco would be up here.
Yeah.
Yeah.
LA's down at the lower left part.
Yeah, even it's actually down by the telescope. There's more. There's more down here. It's a big nebula. Pretty cool, though, huh? And when we talk about these, no, that's not. They're not really there, of course, but it is interesting because we're looking at it as if it's a state, and we're trying to turn it into something that we recognize, and just like we have things like the Monkey Head Nebula. Why do we say that? Because it looks like a monkey head. The Seagull Nebula, because it looks like a seagull. You know, the Daryl Nebula, because what? No. Okay, so.
Still want to break your camera.
Well, speaking of cameras, I've been testing the new AllSky camera today that I built, and it's really coming along nicely. I put the dome on finally, and it really gives beautiful images. So I'm really happy. I'll be putting that in place next month when I go out to the observatory. So we'll have a new full-color, high-resolution AllSky camera that does automatic time lapses and things called kiograms, as well as have individual photos. So that's going to be really cool. Alice Pooper is with us, and so is Sam S. Sam S has been here a while. I just didn't get to say hi.
Bonnie's here too.
Bonnie's with us? Oh, there she is, on Hot 77. Yeah, see, everybody sees their own paradolic thing in here. Eric says, I'm trying to picture a house with that much dust. Well, actually, your house has way more dust in it now than what you're seeing in this picture for dust, even at the densest part of this cloud. Okay? you have way more dust per cubic centimeter in your house by many, many orders of 10 than this cloud. You'll have something along the lines of 10 to the 19 dust particles and molecules per cubic centimeter, even more. But here in this nebula, you have between 30 and 30,000 molecules in a cubic centimeter. But seeing them from such a distance away makes them look denser. So if your house had as much density as these dense clouds do, your house would be the cleanest house on planet Earth. How's that? That's a mind blower, isn't it? Yeah. Cool. All right. Well, 35 is working fine here. We'll have. Let's see what our filter on full width half maximum is doing for diameters. Oh gosh, bring that way down. Okay. Looks like we got past the wind. This is just the filter, the not to go past diameter. You know. So Goblin, this is what, your second time with us? And what do you think so far? What do you think of the SkyTour live stream? I guess you're going to be biased because your first time here you won binoculars. And Marianne, if you're still in the chat, could you please check the email and see if Goblin's email came through for us, please? Because if it has, you got to get that to Calibos and Tiffany. All right. And Shane D45 says, when will Pons-Brooks be visible to naked eye? That's a very good question, Daryl. We talked about Pons-Brooks, the comet.
Yes.
And so it's visible now, but isn't it really close to the western horizon?
It is.
So we would have to see it while the sun is still up, practically.
I made a comment in chat that somebody, I don't remember where I saw it today, said that Comet Pons-Brooks may be visible during totality in the April 8th eclipse.
There you go. Okay.
Let me look.
All right, we're waiting for more details to come in. Look at this. Wow, let me zoom in on this just to show you little features like this. As we zoom in, look at this right here. That's incredible. These details in here are just incredible. Yeah, go ahead, Daryl. Sorry.
Comet Pons-Brooks is now in the constellation of Cygnus. So it's a little bit higher than Lyra, but it's still low in the west, or west-northwest. Its latest observed magnitude is 9.2. It's not visible naked eye. It should be visible with the help of a binocular or a small telescope. It's out of field of view of Marc's telescope, though. It's too low to see over the wall.
Yeah, we have limitations. In general, astronomers don't like to look below 20 degrees or lower on the horizon. In fact, it's usually a lot higher than that. When I was working in the observatory, if something was 20 degrees above the horizon, we didn't even consider looking at it because we were looking through so much air that the images we received would be poor. This image here, look at the telescope over here, okay? It's looking practically straight up. So we're getting all this really, really intense detail in here. You see that? That's detail we would not be getting if it was closer to the horizon. This would be fuzzy. And that's no help.
It's actually, Pons-Brooks is right under Gamma Cygni right now. But it is very low above the northwestern horizon.
What's its altitude?
Right now, from Colorado Springs, it's 5.5 degrees.
Oh. Okay. So not
Kicks and giggles.
doable. We've never seen such details in here. Look at that. That's really cool in here. Let's move this down just a little. This is to help reduce noise a little bit. Wow.
Yeah, on April the 8th, the day of the total eclipse, Pons-Brooks will be to the lower left of the moon and the sun pair. It'll be about 60 degrees elevation, though, so it should be quite easily visible during the eclipse.
Okay. So we should be planning on doing an eclipse stream.
It'll be not far from Jupiter. Jupiter should be plainly visible.
What time is the eclipse starting for Arizona? Do you know?
Well, it won't be total. I set this up in the Sky Live. It looks like maximum eclipse from here in Colorado Springs is going to be at about 12:30 in the afternoon.
Okay.
I know by the time it, the farther, it's heading from southwest to northeast. And by the time it gets up in the northeastern U.S., it's going to be an afternoon or even a late afternoon object.
Okay.
The eclipse is.
Well, we're going to name this now. This is the California Nebula, for reasons we mentioned earlier. There's a lot of really interesting detail in here, Daryl, that we just didn't catch before.
Uh-huh.
Yeah. I mean, it's like a billowing pillow of hydrogen. Hey there, Cindy.
My pillow started billowing. I think I'd sleep on the floor.
Good point. All right, let's push some of this detail. Okay, and let's bring this one in. Now what am I doing here? See, here's our curves, okay? You see a red curve, a green curve, and a blue curve, RGB. And we have this average curve here, which is white. This yellow line represents the amount of data we're actually picking off to see this image, right? If I move this curve in, you'll see the yellow line starts to intersect more of this data, and that makes this image brighter and brighter and brighter, see? Go too far, and too much data comes in, and it overwhelms, and the image breaks down. So we want to meter that appropriately to have an appropriate amount. This is like the middle levels of brightness. This is the dark level. If I pull this back off, and you see it's coming off the white curve here. As I pull it off the white curve, you'll notice that the background gets brighter and brighter. That's because we're artificially injecting a backdrop, a light into this. If we keep coming back, right, you'll see it gets almost washed out, as if we're seeing it through light pollution. But we don't have light pollution out there at all. Our sky looks like this, okay, out there all the time. We have what's called a Bortle 3 sky. The lowest level is 1, 0 technically. But there are no real zero spaces because we have something called sky glow that takes that away. Bortle 0 is in space, facing away from the sun. Here, this Bortle 3 sky allows us to see fine details in just a few seconds. It's unheard of to take a picture for 35 seconds with this much detail in it. Yes, we're stacking them, but the first picture had detail in it. And the reason is because our telescope is not just an ordinary telescope. In fact, I've mentioned this before, our telescope is the only one on planet Earth that is set up to run as fast as it's running. That doesn't mean that there's not other observatories with fast systems. There certainly are. But we have a telescope made by a company called Meade. And our Meade telescope is the only one on planet Earth that has ever been converted to run at a very fast photographic speed. And the company that does that is the only one that does it. And they have never had another Meade go through their shop except for ours. And they did it for us. And they've been consultants with us. The company's called Starizona. Starizona. Great name. That's ST Arizona, Starizona. And they're down in Tucson, Arizona. Great people. Dean Koenig runs it with his son and a few other people. And David is the guy who has worked on our Meade telescopes down there. They're really geniuses when it comes to this stuff. They don't just try to sell you equipment. They sell you a relationship. And so it's very, very, it's very good working with them. Okay.
They're not the only one that did it. Celestron did it first. They still do. It's called the Pastar.
You didn't listen to what I said. I said this is a Meade, and it's the only Meade on planet Earth that's been converted to run at F2.
I heard that.
Okay. That's right.
I heard you say that they were the only ones that did it.
They're
the only ones that did it for a Meade, yes.
That's correct.
Never mind.
All right. So, let's bring this. I'm well aware of FASTAR. And the next system is going to be a Celestron 11. And we've already got that lined up to purchase it. And I'm going in February to inspect a site for potential deployment of another telescope. And if we like it, we are going to deploy it there. So it's another dark sky site, another Bortle 3. And it'll be excellent. But that one's going to be able to see all around the horizon. I'm still contemplating taking this telescope here and adding what's called a lifting column to it, so that once the telescope is up and running, we can literally rise it up in the air on a hydraulic lift, and it will then have an unfettered view of the horizon, because Daryl wants to see Omega Centauri.
I've seen Omega Centauri. Marc wants to see Omega Centauri.
Marc wants to see Omega Centauri too. Yeah. And Centaurus A. Above it. MPG, what's happening? Nice to see you, man. Good to see you. Thanks for coming in. Hey, guys, make sure you subscribe. You know, I mean, and you know what? I got to say, you know, consider joining our Patreon. I mean, we don't make anything from this. We're trying to do this because we want to bring astronomy to the masses. So it's our dream to do that. We have one active observatory right now, and that's this one right here. The one before that was the one that's actually here with me right now. The telescope's in the office here with me, my bunker, where I operate out of. And the telescope here is been rehabbed and ready to go back into a building. And we're going to be bringing this building online as soon as we can get the final design implemented. And I have a metal shop here in town with 5,000 watt laser cutters, and they're gonna laser cut all my pieces to make the structures. And then we have to make our petals. We're going to have a flower petal opening thing, and the telescope's going to be up in the air a little bit. So when they open, we'll have an unfettered view. That means we'll have wind to worry about, yes. But because we're using the full width half maximum filter, this guy, okay, you can see that some of our shots did not pass the full width, and so they ended up getting knocked out of our stack because they would have made the stars less than round. Okay, so there we go. So 33 are done, and we're going to say that's it for now. We're good. Okay. So there, the FITS file has been saved, and I'll save it exactly as seen. There we go. Back to our histogram, which gives us our curves. Nice. And we're going to pop out of that and go for our next object now. Yeah, that's beautiful. Very, very pretty. Oh, yeah. You know, this camera we're using is called the ZWO 183 MC Pro. Okay, it's a thermoelectrically cooled telescope camera, and it's made to look at deep sky objects. And we are extremely happy with this camera because I went on the prowl looking for a camera that would actually give us a perfect balance of parameters so that we could get the best possible images. And this is the camera. The math works out perfectly such that it has a rating for the stellar images that is exceptional based on all the parameters and all the requirements. So let's go back now and let's bring up our planetarium.
Elisha Venus has a question of you, Mark.
Alicia, what she got? Oh yeah, there it is. Mark, what's in the biggest learning curve with the new camera technology? Oh, the biggest learning curve actually is just in the types of things that it shows me for the amounts of time we do it. Now, keep in mind, this is a public display telescope. I'm showing people the telescope, and I'm showing them all these things that are in the telescope, and I have to know what they're going to expect to see. You know, I have to know what they're going to expect to see, like this guy here. You know, and that's the thing that's interesting. I don't necessarily know what that's going to be, so I have to spend a lot of time with the camera alone down in my bunker here, doing a lot of photography, learning a bunch of new things about how this software reacts with the camera. So there's an awful lot to do, but it's all right. That's a great question, Alicia. I don't think I've ever been asked that question, actually. All right. I'm waiting a little bit longer, and then we're gonna go on to Witch's Head, and then we're gonna go on to the Boogeyman Nebula. Okay, this is called the Northern Trifid Nebula. Why is it called the Northern Trifid? Well, because it's immersed in a dark cloud, and it's a hydrogen emission nebula immersed in a dark cloud. And we're going to photograph the Northern Trifid. Again, it's almost directly overhead, so we're going to see some really pretty detail in this one as well, I imagine. Okay.
Eric had a question earlier that we missed.
Okay, sure.
May I just read it to you? It's quite a ways
No,
up
please,
in chat.
please do.
How long does it take to go from a cloud of dust, like what we saw in the California Nebula, to a star undergoing fusion?
Oh, that's a wonderful question. It takes it takes millions of years for condensation to occur, the gravitational contraction. And depends on how much dust you start with. If you start with a lot of dust, then you could do it in a few million years. If you don't start with a lot of dust, you may never do it at all, or it may take hundreds of millions of years of contraction. So it varies based on the amount of dust that's available to start a contractive cloud. And then to make a star, you need hydrogen gas, not dust. So with dust comes hydrogen gas, okay? Because hydrogen is the most plentiful element in the entire universe. So there's going to be dust mixed in with hydrogen almost everywhere you go. And if the hydrogen gas is more dense than the dust, then you might see the red glow of an emission nebula. Or you might just see the dust reflection nebula that we see, the blue. If that's the case, you might see that at times you might have both. You'll see the reflection nebula and you'll see the emission nebula mixed in, like with the Running Man Nebula above the Orion Nebula. And then you get some really interesting color effects. Okay, we're going to start this one. Just
sometimes,
Trifid. Yeah, go ahead.
Correct me if I'm wrong. Sometimes in active emission nebulas, like the Eagle Nebula, the Pillars of Creation, and similar, we can see things called Herbig Haro objects, which are nascent stars coming to life inside dust clouds.
Yeah.
Very thick dust clouds. And I got that right, didn't I?
Yeah, you did. The Herbig Haro objects are wonderful because they are the precursors to stellar objects, to stars. They're called protostars. And we see that this happens in some places, quite a lot. The Cave Nebula has Herbig Haro objects in it. And I don't think we can see the cave tonight. Maybe we can. Might be.
I sent you that picture last night of it. HH148, I think it was.
Yeah, HH means Herbig Haro.
Yeah.
Herbig and Haro were two, obviously, astronomers that learned about and studied these young stellar precursors, protostars. And what's funny about Herbig Haro objects is that when a star forms, it's not just a condensation and all of a sudden, pink, it turns on. Condensation meaning material coming together. Sometimes a lot of activity is created inside of these clouds. And as this cloud and dust is compressing, sometimes you might get these jets that shoot off the north and south poles of these spinning disks of material that are making a star inside. And we see that with Herbig Haro objects as well. It's that quite a lot, actually. All right, here's the color corrected for this northern Trifid. And that's really pretty. I'm going to drop this down just a bit to kind of dump a little bit of the noise off. Look at that. So, now when you look at this, guys, one thing to notice. Let me back out so you can see it easier. Okay, first of all, let's go back to this much. One thing you notice right away, up here, there's like a bluish nebula around this star with a black thing right above it. Then there's this reddish thing over here. Why are we seeing blue? Why are we seeing red? Well, you know why the red now. The red is that emission nebula caused by hydrogen gas that's ionized. Right, when the electron comes back into the atom, which is inevitable because they lose energy when they bounce around out there, they end up giving off predominantly red light, and that's what we see there. But then we see this, and you see this blue glow. That blue glow means there's dust here too, because that is the dust that's scattering the blue light of the star. We call those reflection nebulae. And so you see that means there's dust here, but is that the only place? Well, no. If you look in this field, where's the dust? the dust is everywhere the stars are not. You can almost trace where the dust is by just looking at this image, and you can see where the dust is coursing through this field. And in part of it, a star has formed and is powerful enough to ionize this hydrogen gas around it, and that's what we're seeing here. So these are processes that the universe undergoes all the time. The ionization of gas and the reflection and scattering by dust of starlight. Now, to see what else is here, we can just artificially pop this up really high. Okay, and now if we back out a little bit, this is of course a horrible picture, but you can see the dust goes all the way up in here and all the way down here and over here. So there's a lot of dust here. All right, and we could actually pull all that out during processing. This white glow you see over here, that is called amplifier glow. It's a glow of our system. It should be removed automatically, but unfortunately, that is only set up for 25-second exposures. I'm doing a 35-second exposure. I'd have to do a 35-second exposure at 300 gain to get what's called a flat frame and a dark frame, so we can actually subtract these away. We're subtracting a lot of it. A lot of it's going away. So
I assume it would be fair to say the little star to the upper left of the emission nebula, there where the reflection nebula is, if we were a lot closer to that, might look kind of like the Pleiades, perhaps.
Yeah, there'd be like one of the stars going through the Pleiades dust. Correct.
It's the same process.
Same process. Yep, you got it. Yep, that is true. And if you notice any other stars that have a sort of a fuzzy glow around them, then those too are immersed in dust. Like this one, looks like it may be within some dust as well. But that could be an illusion. This one is clearly in the dust, though. You can see there's a dark nebula above it and down here. Beautiful. The Clementine mission? Is that what you're talking about?
Yeah, well, I made the point. I think it was called the Peregrine mission, and I kept wanting to call it Clementine.
Oh, okay.
The lunar lander on the ULA launch.
Because you guys may remember the Clementine lunar mission. Just as a point of historical record, this telescope here that you see, our Western telescope, is on the land owned by the guy who created the Clementine lunar camera. He was the developer of the Clementine camera on the probe. So he's quite a well-known guy. This is pretty. This is looking good here. There we've got 9. If we go to our full width half maximum, you'll see that 1 was rejected. Went over 7.13, and we've been at 6.95. I don't want to go to 7, and that keeps our stars looking nice and round. Here's another star that's embedded in a little blue that shows up after we do this. Now, just because it's blue doesn't mean there's no hydrogen there. Okay, there might be, but the blue may be overwhelming the weak hydrogen. It might be lower density. So the blue shows up as higher, quality to your eye. All right, so if we back out now. Now you can see the dark. See right down here? It's like a Y right there. You can see that the emission nebula from the northern Trifid goes all the way out here and all the way out here. Really pretty. Very nice. Very, very pretty. Okay, so oh, you're talking about the failed probe?
Yeah.
Daryl is talking about the failed probe mission. The launch was good.
The launch was great. It was very impressive to watch.
Yeah, tell everybody.
Hmm?
Tell everybody about it. I don't think some people may not even know what the mission was.
United Launch Alliance had its first launch of its most recent rocket called the Vulcan. They launched it late Monday night. It was after midnight Sunday, I think, so Monday morning, about 2 in the morning Eastern time. It was a heck of a launch. It achieved its primary objective, which was just to have a successful launch on its way to certification by NASA. They have to have one more successful launch to be certified. Then they can send it to the International Space Station stuff. It was sort of a bonus. They had this little lunar lander, privately owned lunar lander mission on top of it called the Peregrine. And you might have heard it also had the ashes of some people on it. They were going to sit on the moon. And the Navajo Indians got angry about it because they thought it was going to desecrate the moon. I was up late enough to watch the launch and watch the Peregrine separate. And at one point, to fill some time while they were waiting for something to happen, along the mission between point A and point B and C, some guy came on and was talking about the thermal blanket system they put on the lander and how great it was. And I still don't really know the details that well, but evidently something on the thermal blankets covering the spacecraft interfered with the thruster rockets on the lander, and they could not acquire the sun to shine directly on the solar panel to charge the batteries, and they started losing power. And B, while the lander was trying to find and put the sun in the right place, to shine on the solar panels, they burned up too much fuel. And evidently this thermal blanket was interfering with the thruster or something. Again, I don't know the details. But by the time they got the Peregrine stabilized and the sun hitting the solar panels and charging the batteries, they wound up with not enough fuel left to do the lunar landing.
Too little, too late.
Yep.
So they crash landed?
No. It's flying out in space now. It was going to take over a month for it to reach landing. But
Okay.
It is out there. It's still headed in the general direction of the moon. Last I read, it was a couple 100,000 miles out. So it sounds like it's closer to the moon than Earth now. But it's going to be one of those rather involved multi-Earth moon orbits.
This wasn't
get it
the
into the proper parking orbit, and it was supposed to land like a little over a month from now, and it's not going to happen anymore.
this wasn't the Celestis launch, was it?
No,
Okay, because
I believe it was
Gene
called
Rodden-
Peregrine, like Peregrine.
Gene Roddenberry's ashes and Majel Barrett's ashes were on a Celestis launch along with Jimmy Doohan and Douglas Trumbull. And that launch was on the 8th, I believe. Okay, we're getting some nice shots here. This is coming in. There's 18 frames captured. So we have a lot of dust in here. I'll show you real quick. You can see all that dust in there.
The Navajo tribe objected to the idea of depositing people's ashes on the moon. It's a holy object to them, and they thought it was desecrating the moon.
Well, they've already done it by accident.
Yeah, but they very politely were told to, take a hike.
Well, why should it be any different, right? They've been telling Native Americans what to do and where to go for hundreds of years so far.
Well, that's a subject I probably shouldn't even have brought up.
It's okay. My mother was Native American, you know that.
Yeah.
Everybody has their own opinions. I'm not married to the concept of indigenous rights and stuff like that. They were a conquered people, unfortunately. So see, without the color,
it's called history.
yeah. So without the color, this is what that image would look like. Put the color in, all right, and now you have this. Now put a lot of color in, right, and this is a lot of color. Now, if we did that with the Orion Nebula, it'd be a blowout. You'd see a lot of color. Oh, Calibos, don't worry. I think that because the launches were kind of close to each other, you might have mistaken that. No worries, man. No worries. Okay, so we'll give this another couple, then we'll move on. Let's go see what we'll do next. Okay, so right now we are doing this object, the Northern Trifid. We're showing more information than this is. Okay, and that's way up north. Let's see if we just swing around the pole a little bit here. We might be able to catch something again before we get into Orion. We gotta let it come up a little better. There's Pleiades. Merfac. I want to see, let's bring up our data here and let's look at the deep space objects. Let's take Sharpless 2 catalog and the Barnard catalog and add them to our list. And Lynn's Bright Nebula and Lynn's Dark Nebula. There we go. So now we'll see a lot more objects in here. These are all Dark Nebula. Now, if you saw my Facebook post, I talked about how much Dark Nebula we see. The galaxies are stuffed with them. There's trillions of galaxies, and we see lots of these dark lanes throughout galaxies all over the place. But in fact, this dark dust only constitutes 1% of the mass in the universe on all of this. So that was pretty interesting how it's focused and concentrated in galaxies, but the bulk of the matter is not within dark matter. Okay, we're at 24, going on 25. We'll stop at 25. And let's make sure we captured that one. Yep, we did. Okay. Northern Trifid, you are our historical record now. Save exactly a scene. Come out. Go back into our little night vision, not night vision, our 1 second shot here. It's our finder, as I say. All right. Let's go back over now and look over here and see. There's Capella again. And let's come down here. Back out a little more. Let's check the angles on Orion, and so forth. We are high enough. Okay. All right, we are high enough to do the Boogeyman.
You might do Casper again first. Izabela wanted you to image Casper again.
Oh, that's true. Casper the Friendly Ghost Nebula. Okay, Casper the Friendly Ghost is a very interesting nebula. All right, and it's right here. So let's go there and see if we can get there without incident. It's 50 degrees up, so that should be more than enough. You'll see our telescope is going to skirt the top of the building but not get down below it. Okay, and so we should see it. And there it is. This star here and this star here are the two stars within the Casper the Friendly Ghost. Right? And we're going to put those stars right up here so we can capture what's below them too, because there's a lot below them that's really interesting to see. If you folks like this, please subscribe and click the like, man. I mean, it all helps us. We want to be able to showcase what we do to the world. We're not asking for anything for it, except for you to enjoy. Sam S says, "Is there anything is there anything in Orion's bow worth a look?"
Orion doesn't have a bow.
I think he's talking about Sagittarius, but I think he might be talking about this section of Orion here. See, that looks like a bow, right? But it's the hand, right, holding it.
Yeah, it's a animal skin lion, I think, or something.
Yeah.
In his left hand there, and he has a club in his right hand to our left.
So most of the interesting things in Orion are here and south, because this part of the region of space, if I back out because it's huge, okay, this region of space here in Orion, okay, or all in here, is all part of something called the Orion Molecular Cloud Complex. And the Orion Molecular Cloud Complex is a massive area of dark nebulae that is where we find lots and lots of beautiful nebulae that are dust clouds, and many molecular clouds, molecules, complex molecules of things like carbon atoms and silicon atoms, and many ices of methanol, formaldehyde, water ice, carbon dioxide ice, ammonia ice, and these things are really the fundamental building blocks of life. And that's what we find in these dark clouds. That's why I say that life began in the dark. Okay, we're gonna let this come in. We're gonna actually go to the west just a little bit, center this up a little more. We won't see Barnard's Loop up here anymore because it'll be just at the top edge if this is over to the right. But this here, this region right here, is full of dust. Let's go see it. Alright, so in order to do that, we're going to do a 35-second photo here. You'll see I'm typing in 35,000, and that's because 35,000 is 35 seconds, 35,000 milliseconds. Alright, so that's 35,000 milliseconds. Okay, and I noticed that we're guiding over here now. We have these numbers now that are changing. That's our guider. Let me try something here. Let's try and bring in some better quality on that. Okay, So now when we come out of this finder mode, we are starting our capture. See over there? Right there. The progress bar is starting to move across in the lower right. And that progress bar tells us that we are capturing now on the chip. This is the buffer on the camera that's about to come up. This is the Trifid, northern Trifid. You can see how much dust and stuff is in here. It's actually quite a lot of detail. And that's been saved and up on the server right now. I'm certain of it.
Izabela says, please, Mark, compose it more in the center of the frame. She also said to be sure you have the gain turned up.
I do. I have the gain up at 300, Izabela. I did that for you. I announced it earlier in the stream that I did this for you. Mike Townsend. Oi, what's going on, man? Nice to see you. Okay, I think we... Okay, we're at 8. So I'm going to just bring this up just above 8 for the moment. Just to see if we're going to be one of those. Yeah, okay. Just a little more. Hello, Christine Anderson. How are you? Nice to see you, Mike.
Looks like the wind picked up again.
Yeah, that's okay. We're also more on the celestial equator, so our full width half maximum is going to be a little larger down there because we have more movement that has to be accounted for. There we go. Okay, so here's the first one. Now you'll say, well, wait a minute, it's off the screen. No, it's not. It's here, see? Now, Izabela, I did it this way so we can see the dark nebula down here and that major brown dust over here. So that's why this is off-center a little bit. Because the real exciting stuff is actually in the dark. I'm a big fan of dark nebula, guys. All right, let's darken this up. Okay, now if you notice, right off the bat, we're starting to see some really interesting things happening in here. Let's try to bring those out a little more right now. Okay, and now you can start to see this really phenomenal structure developing here. It will become even clearer as we do more exposure here. Oh, Calabo says Mike Townsend is actually a winner of Celestron Cometron 7x50s from he and Tiffany back when we were giving these at contests in our Facebook group. See that, Mike? Previous winner. So good to see you. Actually, there's a lot of tendrils in here, Izabela. She says there's not a whole lot in here. There really is. And there's lots of filamentary detail in here. And we're going to try and bring it out. Let's color correct. You can start to see it now. Casper, the friendly ghost. Okay, so we do this. It's going to make it brighter.
Who is the tough ghost?
Oh, you know what? You asked that last time and I didn't get it. Does it begin with an M? M, like Marty or something? Something stupid.
Spooky.
Oh, that's right. He was a thin one, right? With the little pointy hat, pointy head.
No, he looked Irish, shall we say. He wore a derby hat, and he had freckles, and he had a boxer's nose.
Yeah, big nose, bulbous nose.
Spooky.
Ah. Look at these details in here, guys. See that? Look at that. Look at this. Look at this. Wow. This detail will clarify itself quite nicely shortly. Look at little filaments. Several filaments here.
The little red thing down below that.
This?
That. Is that a Herbig Haro?
I don't know. We'd have to look it up and see. They do occur in dark nebula sometimes. No?
Something red lighting it up inside.
Yeah. Alicia is leaving us tonight. We'll have a great night. Thank you, Alicia. Good to see you. Thank you for coming, Alicia. Okay, now you can start to see, if we back out, you can see more detail. Look at that. See that now? We got all kinds of detail here. Let me try to bring that detail out just a little more. Okay, there we go. Do this, pull that back a little. Look at that. See how mottled that looks in there? That's just an incredible, incredible thing in there. Yeah, that's something. I mean, this object reminds me of another one that we have seen often before called the Iris. The Iris is another location where a star winked on inside of a nebula, a dark nebula, and it was having its light scattered, its blue light scattered. And it's in a tremendous location where there's lots of tendrils of brown dust. And it's really amazing. Mike, thank you. Very, very complimentary, Mike. Thank you so much. It's the universe live in real time, and that's what we do. This is happening live right before your eyes. This isn't, some kind of fakery. This is the real thing. And sometimes you'll see a satellite go right through, usually Starlink these days. Renee Cruz, the proof is out there. Have you seen the show? History Channel's The Proof is Out There is a great show, and I am their photo and video analyst, so I do I appear on a lot of the show, and I try to point out a scientific approach to what might otherwise be, a case that's just taken at face value and called a UFO when in fact it may not be. So as the Mutual UFO Network's chief photo and video analyst, I'm also the History Channel's photo and video analyst as well. And this actually is a very important thing to do, because you have to know what cases you should pay attention to and what cases you should look at with a little bit of a critical eye. And there tends to be less people with critical eyes in the UFO field, if you know what I mean. But it's all right,
Speaking of, have you seen that jellyfish?
Oh, yeah. I've been analyzing a jellyfish all day today.
What do you think of that?
I don't have an opinion on it yet because I haven't finished the analysis. But I don't have a definitive thought. I mean, I know Jeremy Corbell, who has brought it out. And if you look at it, okay, people say it's absolutely still, and it floats over this town. It's absolutely still. And I said, yes, but you've got to look at it a little more critically. what else does that kind of behavior? There's other things that make that exact behavior that are perfectly natural, kind of. They're normal, not natural. And like what? And I said, a bunch of balloons flying through the air. Oh, these aren't balloons. Maybe not. But what you're seeing here is something moving in a uniform air column. And the wind is pushing it along at the same speed, every part of it. So when you look at an object moving in the air column, it isn't going to move. It's not going to roll and bounce around. It only does that if the air is causing it to move and bounce around. But if you're in the air column, it doesn't happen. How do I know this? Well, because air columns act like solid masses of moving air. Once you're moving at the speed of the air column, there's no wind at all. Even if you're in a 60-mile-an-hour air column, moving 60 miles an hour across the ocean, across the sky, in your balloon, you could drop a piece of paper and it would just flutter to the ground inside the basket. I did it. I did it from 2,500 feet up in a hot air balloon. Okay, we were moving about 40 miles an hour across the ground. It was actually quite a rapid pace. We were in an air column that was moving that way, but the whole air mass was moving. So I dropped a piece of paper, and it just went, and it fell right down to the bottom of the basket. But we were all moving at that speed. You know, it's the same reason that or the same analogy to the Earth moving many kilometers per second through space. Yet you don't feel it, right? Because we're all moving at the same speed. So, that's how that works. This is looking nice. Look at, let's dump this here for now. And in fact, I'm gonna actually get rid of my telescope for a minute, and let's just try to look at this thing alone.
Izabela has a comment for you, and
Okay.
Also Shane has a question for you, a little ways up.
Okay.
Mark, could you excuse me a moment, please?
Sure, let me go see what Shane had asked. Mark, do you have any issues with satellites crossing? Oh, yes, every night, Shane. Every night. I'm surprised we haven't had many here. I want to show you something cool, though, if we actually get to do the Orion Nebula tonight. The Orion Nebula is pretty interesting because we have a lot of geosynchronous satellites that are right there. So as we watch Orion, you'll see these little dashed lines appear on the photos. Those are geosynchronous satellites. And if I come over and turn off our telescope tracking so that we're just looking out into one spot in space and not following the stars as the Earth rotates, then we'll see that there's a dot that stays right there, and as the stars will keep going by it. Well, that dot is a geosynchronous satellite, and the stars will just keep drifting by it to the west. Okay? Really fascinating. And then you turn on the tracking, and all of a sudden the stars stop drifting to the west, and the satellite starts moving, because now you're following the stars again, and you can actually literally see that the telescope is capturing these geosynchronous satellites. Hello, Jessica S. How are you? All right, so let's okay, we've got 15 exposures here. A few more to try and lessen the noise. Because when you go to settings like we have here with a gain of 300 right here, that's pretty high. All right, so we want to take more exposures to offset the extra noise we get in our image. If we went with 200 or 150 like we've done before with this camera, we would find that we wouldn't have as much noise, but we also wouldn't have as much detail because it's not as sensitive. That's all. That's all, number one. Hello there, Mr. Django. How are things over in Belgium? It's nice to see you. Okay, we actually had a failure of our full width half maximum because we were just a little bit too high. I'm going to leave it right there for now because, see, you're actually seeing when the wind comes up. You're actually seeing it right there. We get all these greens and all of a sudden a bunch of reds come in. That usually means that the wind is picked up. All right, so we'll let one more come in and see if that one's going to be a problem. Yeah, 8.35. So what we're going to do is we are going to just raise this ever so slightly to 8.58. So now we should be able to continue growing our frames. All right. Izabela asks a question. The gain the previous time was 250, now it's 300. Is this a significant difference? Actually, it actually is. If you see in terms of this particular camera, it is a somewhat significant difference, I'd have to say. And we did one in 2022 where we used a gain of 400, and he said it was great, but that's going to bring significant noise. I'm happy to try that for you tonight, though, Izabela, as a special request. We can do one for at 400 and see what it looks like. It'll take longer for it to get in and noise-free, I should say. And subtle details like we see in here are not going to be visible because the noise is going to overwhelm that. So we'll do that. Maybe we'll do that with the Boogeyman. We'll try that with the Boogeyman. We'll go up to 400 for you. All right. Okay, we are up to 18 stacked. Let's see if we, yeah, the last three we've captured fine. So we'll go to 20 with this, and then we'll move to 400 and try the Boogeyman. Why not, right? We have ways of getting rid of noise. It just doesn't, it's not as pretty. We can do it. Besides, Daryl wants to do the Boogeyman.
Were you going to do Casper with the Casper at 400 first?
No, I'm just going to go to the Boogeyman and go to do that for 400. Look at this.
Okay.
Look at these details up in here. These are really pretty. No, we've all seen the Casper, the friendly ghost, for the last several minutes. We're going to go to a new object. Hey, Steve Tuttle, how are you? What's that mean? I mean, okay.
Well, further opponent says not.
Okay. Okay.
Somebody asked a question earlier. It might have been Eric. I forget. He wanted to know if you could marry the stacks from different telescopes, and I suspect with different cameras and maybe different focal lengths or field sizes.
You could do that. The only trouble is optics are very particular, and the way one telescope will render an object is different from another telescope that will render an object, even with the same types of lenses in them. So you really have to use the same optics to get a stack like that. So, but you can do this, okay? If it was Eric, you can do this. You can take a stack on night 1 and take another stack on night 2 of the same object, night 3, and keep doing that. We could accumulate all these stacks of, say, this object, and then we could turn around and stack them all again together to make even more. That's so true. Yeah. Mr. Django says, I'm so happy because after 3 months of rain, I got 2 full nights of stargazing. It's amazing how incredible that makes you feel, huh? It's true. It's absolutely true. All right, let's redock this here.
Here's a question I posed a minute ago.
Bring the telescope back. Yeah.
I think I have heard of imagers taking data sets of of the same objects, taken at different times at different scopes, and somehow successfully marrying them together.
Well, it's possible, but they have to mathematically reduce the one set to the exact field size and field curvature of the other one.
Yep.
And also rotation, field rotation. And if they do that, then yeah, they can probably do that, but it's a lot of work. I mean, if you think about it, the Event Horizon Telescope was doing that with radio data. So, all different telescopes of different types, not all the same, and they had to normalize all the data to work together, All right, let's
I gotta remember, I should look into that later.
yeah.
That Bray Falls guy, I want to say I saw him talk about doing that.
Okay. Probably did. Okay, so there we go. We got that out there, and the actual image is this one. This is what's up there now. You can see all this detail with really detail out here. Okay. Yes, I know that we could have gone a little higher to see more detail there, but I did want to capture this stuff mostly. Okay.
Favor before you split.
Yeah.
On Stellarium, zoom in on that little red area I mentioned earlier. See if that might be a Herbig Haro.
Well, it's not going to be listed on this one, I don't think. Let's go here. I'm talking about this guy.
Yeah. Okay, I guess not. Carry on.
Well, actually, we
They do
probably don't
show
have
it.
the catalog. We probably don't have the catalog activated. It may show it. Isabella, that's okay. I just wanted to do that for you, and Isabella said thank you for indulging. Well, you know what? It's okay. She actually asked for a higher, a higher sensitivity for this image, so we did it. So now let's go to the Boogeyman. Do you remember the Lynn's Dark Nebula number for it? Was it 1600, 1200?
1622, I want to say.
Or is it 1522? No, 1622. I think this is it right here.
Yeah, see,
Hey,
it's
where'd you
right
go?
on near the side of, there's Bernard's Loop. It's right on near the side of
Right
it.
there, yeah. All right, we're going to do 1622 right here. All right, we're going to... All right. And we're going to go now. Now, before I do that, let's just... we've been stacking this 27. We're going to save one more time. And save exactly a scene. Then we'll dock our... Here we are. And we'll get rid of it. And let's go back to Finder mode so we can actually see what we're looking at when we get to it. Okay.
Calibos has a question of you when you have a moment.
Oh, yeah, we can see Steven's Quintet when it's up. Absolutely. We've actually imaged it quite a lot. All right.
I seem to remember looking at it. It was actually quite small, wasn't it?
Yeah, well, we were imaging it, but I don't think we ever saw it with this camera. This camera gives us more field of view. Maybe we did. I'm not sure. Do you remember if we did? I don't know.
On this camera, I don't remember.
Yeah. Okay. All right. So, LDN 1622, Lindstark Nebula 1622. These are catalog names for all these different objects that are out here. And we're going to go to this object now. There's the current location. We're going to go up here. You'll watch the telescope moving. You saw that star go by there real quick. And I'm trying to remember. Is it here? And then up into there. All right, we're going to actually just take a quick shot here just to make sure we're exactly where we should be. All right, we'll do a 20-second shot. Kind of a finder. And we may change it. I'll just stack it anyway just to see in case we're in the right spot. Full width half maximum. 8.58. That should be enough. Nah, we're off by a bit. Well, I don't care about the filter right now. I just want to capture our object and see what we got. So I turned the filter off, so we'll get an image for sure. Okay.
Good night, Izabela.
Isabel's leaving us. There it is. Good night, Isabella. Thank you for coming, as always. Okay, so here is... Yeah, so it was down low, the thing I was talking about. The entry point of it. Alright, so there's the Boogeyman right there. And that might actually be a good composition, Daryl. I think it will. Let's go back out a little. Alright, let's color correct it. And let's process. Yeah, it's not bad. Maybe take the star out of the field, move it a little bit to the right. So we'll do that. So we're going to head to the east. I got to tell you, it just never gets old running a telescope from 2,500 miles away. Crazy. All right, I'm also going to do one more thing.
Curious to see what the scale on this camera will do compared to the last one.
Yeah. That's why I moved it over, because I want to capture most of this in here. This is most of the object right here is in here. Okay, the other thing I want to do is let me zoom in and make sure that we still have good focus. Yeah, we could use a little adjustment, so that's good. So we're gonna do this, and there we go. So it's out of focus there, and so we're gonna go down here and to our focus algorithm. So we'll let that do its thing. So it identifies stars, and it checks the diameter. I kind of like that full width half maximum filter does, but with star images. in this way, we're just trying to find the whole star image and make it for each of these samples, these yellow samples. It's trying to minimize the size of the star image. The minimum size is the focus size. So I have it set up to do 12 samples, 12 sets of comparisons against all these many stars. Right now, if you notice, it says 51 stars, because you don't see the whole field if we zoom out. Okay, let's just zoom out. Let's go to 25%, and you'll see that we have 60 stars picked in here. That's a lot of stars. And so what it's doing is it's building a curve. So it goes from out of focus to more in focus, and then it starts to get out of focus again. That curve will look like this. It'll be a little parabola. And in the middle of that parabola, the lowest spot will be the best focus point. It's going to be right about here. Okay. And you'll see that line show up momentarily. There it is. And you notice it's not right on a focus. It's not right on a sample segment. That's because it's interpreted. So mathematically, it finds the minimum of that line, and that is exactly where best focus is, and we can just say best focus. So it goes all the way across and then all the way back. And what's happening physically in the observatory is the focuser unit on the telescope here is going zzz, all the way out, okay, and then all the way back, zzz, and we end up with the closest possible focus. So there we are. So now when we take the picture, it should look really pretty. And I think tonight what we'll do, let's see if we can capture a 35-second photo. I could either use 35,000 milliseconds or 35s for seconds. All right, we're guiding here. There we go. Our yellow progress bar is going over here. So we're good. And this is a histogram. This is like the over brightening, just to see something that's hiding in the dark. We're going to get rid of that, and we'll go live stack, and we'll clear the past one that was in here because we moved it. I think this boogeyman's going to be pretty. Let's go to our filter and see if we need to adjust anything. We're at 8.58. All right. I think I turned off the filter, so I got to turn it back on and clear it again. But let's see where we are. Did I go too far? Let's go see. I did. I went too far. I got to move us over. Okay, I'm glad I did that. That was silly. Okay, let's do that. Alright. I have to put this star more here. Mistake. Okay, here we go. I'll take those two stars out of the view. Or just barely out of the view. That's good. And then just a nudge up to the north. One more nudge. Okay. And that'll be that. Now we're searching over here. Huh?
That's like a scooch. A nudge.
It is? Oh. I guess. Maybe a nooch? Is that a nudge and a scooch? Hey, James Dugan, how you doing? Hey, Pro. All right, now that we're guiding, let's go back up here and do 35 seconds. And take our stack. Okay. That's our last image of the stack. We're going to get rid of that. Clear this. All right. So 35 seconds at 300 is going to be noisy, but it'll clear up. This should be pretty. This camera's best performance is at like 100, 150. So it does perform at these higher levels. That's what we're trying tonight. There we go. This is the beautiful segment right here. Nice. Okay, let's see. I'll be processing that in a moment. I'm gonna have to step away for a second. I heard a loud noise outside. I just gotta make sure it's not a bear. It might be a bear in the. It's right outside the door too. So if I open the door, it'll probably scare him. Okay, this won't be good. Let me just move this. All right, you see where our black curve is? It's way off. If I was to move that in, okay, you'll see a lot more detail really quick, right? But you'll also notice there's a green cast. That's because we haven't color corrected. If we color correct now, all right, now you'll see that it looks better. All right, but you see the noise. Now what I'm going to do is I'm going to take this and move this right up. This is the curve, and if you cross this, this is the maximum darkness you can have without losing detail. So we can go here, right? But I go just before it to soften it just a little, and I pull this down to drop some of the noise. Okay. There we go.
Scream
That's
real
nice.
loud if you need help.
I will. All right, I'll be right back. Let me just go check. Be right back.
Renee, per your question, I suspect maybe at least, ground-based telescopes, amateurs certainly, can be viewed live with the proper camera. Some professional telescopes, when you're getting up to like the Webb, the Hubble, other space-based telescopes, they are so regimented with their viewing schedules. They have everything marked down, weeks, months in advance, and their observing programs very rigorous.
I don't know, man. He loves my garbage.
Is it a bear?
Yeah, stupid thing. They're very skittish. Black bears don't want to hurt you. They just want to run away. Run away, run away. All I did was open the door. But with cubs.
Huh?
With cubs, they don't run away.
Or if he's hungry enough. There's an old saying, if you're attacked by a grizzly bear, roll up in a ball and play dead. If you're attacked by a black bear, you better fight back because he intends to eat you.
Yeah. Well,
it does happen. There have been a number of people killed by black bears here in Colorado.
Yeah. Here, our black bears are a little different, but they're the same temperament. But what's nice about our black bears is they're. I take my dog for walks in the woods, and it's like almost every time a black bear is on the trail with me. Almost every time. And I give them names. Now I see them. It's Barry. Hey, Barry. Just let them know I'm human. And with the dog, they're really afraid of the dog, and they'll run right away. So I try to keep Dingo from running. She's a cattle dog. She wants to herd them. So she tries to run after them, and I try to keep her away. But typically they're very skittish and they run. But the one time it did not happen that way was when on my front lawn, I had let one of my other dogs out to play back when I had Indy, a black lab pit bull shepherd mix, and she was out there playing, going to the bathroom. It was at 2 a.m, and I ended up feeling the spongy ground after the rain. The spongy ground started bouncing under my feet. I'm going, what's going on? It sounds like something heavy's coming at me. And Indy ran right between my legs, back into the house, through the open door. And I said, that's a good idea. Whatever's coming, man, it's moving fast. And I ran in and slammed the door just in time to hear something whack up against the door really hard. And it started rubbing around, and I didn't hear any noise, but it rubbed around, like rubbing a cloth on the door. And then I waited about an hour, and then when I opened the door, it stunk to high heaven, like poop and pee. And there was a smear on the door. I had to repaint the door, actually. It was a brown smear and just matted and some fur. I realized, wow, that was a bear that charged us out there. And the guy that works for me, that had worked for me at that time, was here until like 10 o'clock the previous night. And when he left, he's going down the driveway, and he basically saw something that he didn't bother to tell me about until the next day when I told him that story I just told you. He said, oh yeah, when I went down your driveway yesterday, I saw 2 bear cubs playing on your front lawn. Oh, well, I met Mom. You know, I met Mom, you idiot. Oh man. So it was pretty intense. So that's the one and only time that I would have been injured by a bear, really. But out on the trail, you just wait and see what they want to do. They don't want you in general. They're vegetarians. They're typically vegetarians. You know. But if the dog gets in the way, they'll eat the dog.
There have been black bears that ate people here in Colorado.
Oh, I'm aware. Yeah. I'm hoping that doesn't happen here. You know, it might be a different type, a different species of the black bear. Or it's all North American black bears. I don't know. Michael Galea, how you doing? And 4 of 20 is with us. How you doing?
Bonnie asked, don't your bears hibernate in Connecticut?
Yeah, they do. But you know what? Bears often do come out during hibernation. It will come out at times. We've had that happen. Renee Cruz, Sasquatch at Marc. Yeah, okay. Yeah. 420 said, my pit bull that passed last year was named Indy. Yeah. Yeah, well, that's a great name for a dog. Our Australian cattle dog is named Dingo. And she looks like a dingo. And she's 13 and a half now. And I got her when she was taken in a drug bust. I got a lot of law enforcement friends, and so they stopped the car, busted him for drugs, and they had a dog. So they immediately take the dog, and the idea is that when they capture animals in the possession of drug dealers, what they'll do is they take the dogs to the pound right away. And this police friend of mine, Dan, was driving the dog to the pound, and the dog just started licking his face. He stops the car and says, I am not bringing this dog to the pound. That's like a kill shelter, and then, I can't do that. So next thing you know, I'm getting a call. Marc, there's a dog that's really cute. I go to meet the dog. They say, I'll foster the dog. Why not? Meanwhile, Indy, who was here, Indy was like, Indy was really excitable, and but she needed somebody to, play with her. And I played with her all the time, but I couldn't spend all the time she needed. Dog time. The time of just laying with another dog in the room with you. So I just fostered Dingo, and Dingo came in the house. First thing that Dingo did was try and take Indy's toys, and they got in a big fight. And I was like, whoa, hey, hold on there. Next thing you know, I said, you know what? That's not a bad thing. They figured it out. And I called Dan and I said, yeah, Dingo's not going anywhere. And for 13 and a half years, she's been here. Indy died a couple years ago. You know, bigger. She was 118 pounds compared to Dingo's 40. And Dingo ruled the roost. Oh, man. Very smart dogs, cattle dogs. Very, very smart. So, anyway. Hey, Dean Bostador. Yeah, you know what? Feeding wild animals is just not a good idea. That's just not good.
No, it's
I wouldn't
not.
do it. You don't do that. You know?
The woman down by Uray, she had been cautioned not to do it by law enforcement and game wardens, and she did it anyway.
Well, remember the grizzly guy, the grizzly guy who said, hang out with the grizzlies? You know, he said he would never be attacked by a grizzly until they shredded him to pieces. So let's be clear.
Yeah.
Yeah. So.
What was his name? Tim?
Oh, the grizzly guy?
Yeah.
I know what you...
First
I
name
don't
was
remember.
Tim, I believe.
Yeah. Anyway, let's look back at this here, because here's the Boogeyman, and this is really shaping up nicely, Daryl. Look at this detail.
Yeah.
I'm glad you suggested it. And let's zoom in down at the lower end of the Boogeyman here.
He's kind of laying sideways right now. That's his head at the upper right. And his right arm is that thing extending to the upper left. That's his right arm. His head on the right, that's his torso. His left arm down at the lower left, and I guess his
lower
leg.
left?
Huh?
You're saying this is left arm?
No.
This was, I thought.
Yes.
Okay,
that's like his left arm right there.
Yeah, left arm, right arm, and you can almost
Torso,
see
head.
eyes. You see a head, eyes, and a mouth.
Yeah.
Pareidolia fills in the blanks so nicely.
Then I guess that'd be his legs there, more on the middle left.
Yeah. Yeah, he kind of looks like those creatures from Harry Potter that fly around in the dark creatures.
I wouldn't know. Never seen a Harry Potter movie.
Well, someone in the chat is going to tell you what they are.
I'm sure. Calbo said the bear guy's name was Timothy Treadwell.
He's right.
Yeah.
That's right. Timothy Treadwell.
Bear killed him and his girlfriend.
Yeah. Because he knew he was smarter than the bears until he wasn't. Wow. I like this music for this object. It's eerie, it's mysterious, it's a boogeyman. Wow. And is it right to kill the bear because these guys did this? I don't think so. They get labeled man-eaters and they kill them. It's like, no, stupid person. This is Darwin. Darwin Award winners coming up.
If a bear is fed on people, they will, they think they have to destroy it. If the bear gets overly familiar with people, it's 2 strikes, you're out.
Yeah,
They'll
they
tag
move
the
them
bear.
out.
If the bear's been coming around, if it's
Yeah.
raiding trash a lot, or if people have been feeding it, they will give it one chance. They will tag the bear. And if
Yeah.
that bear comes to the attention of the authorities a second time, they will destroy the bear.
Yeah, this bear is probably the one that lives out in the back here. I live on a sloping property, and out back I noticed a bear den last year, and it's a bunch of overgrown branches of low bushes that go deep into the hillside, and there was a bear den there, I know for sure. And because he would come out sometimes during the hibernation phase, and he'd be there groggy and all that, but then he'd go back in. So I don't know if it's that one, but when you think about it, I used to have the observatory in the front lawn, and you remember the time, were you with me on the stream when I got trapped in there because there was something walking around the outside of the observatory, probably a bear? Probably the bear.
I don't remember.
Yeah. Okay. Well, anyway, look at this beautiful area of reflection nebula down here at the bottom of the Boogeyman Dark Nebula. This is an area unlike the other one. This is not a scattered nebula. This is truly dust that's illuminated by these stars here. This star may not have ultraviolet and very, very blue starlight to cause a reflection type nebula that would be really blue, but it has enough light to be reflected by the dust, and so we're seeing that. So we see a true reflection nebula here, you know, and this dark nebula is that dark material I told you about. Okay, the dark stuff that's the fundamental building blocks of life in here. Now, what's interesting about these locations is that even if we had an O-type star ionizing this entire region here, if this material is dense enough, it could actually protect any planets and stars, well, planets anyway, forming inside from the O-stars damaging effects such as ultraviolet radiation and extreme solar flux and winds that could rip the atmosphere off of a young planet. So the dark nebula would protect that. And so we see that that's the case sometimes. We see that we have in the Orion Nebula, for instance, we have rogue planets. Planets without a star that were able to form in there. Pretty cool, you know? And it's because even though, well, we don't know if they have atmospheres, but the planets were able to form because they formed within the dark nebula, where the ultraviolet radiation was kept at bay by all those tiny particles of dust between you and your hot O-star trying to evaporate you.
Weren't they finding pairs of rogue planets near the Orion Nebula?
In the Orion Nebula? Yeah, that was pretty interesting how that was turning out. Yeah, I'm getting some three-dimensional look here, like this stuff is suspended between here and the background.
Yeah.
Let's dock this up. We'll leave us in the full screen there, and let's see if we can accentuate that. There we go. Okay. Okay, we got 32 images of this taken. That's actually quite a lot. Let's see where it wants to be.
Nicely.
Yeah.
The bright star on the right, I wonder if that's what's illuminating the emission nebulosity there in the area around the Boogeyman.
Well, I don't know. I mean, it looks like a lower temperature star. Let's go see. It's probably a K or an M type star. That's this right here. Yeah, it's a K2, and it's a 2b, so it's a supergiant. It may not have enough ultraviolet light to actually cause this emission nebula to glow like this. It could be
may just be a
some other
foreground
stars
object.
in here. Yeah.
As you mentioned earlier, though, that little swirl of nebulosity there at the lower right, that's almost certainly in that whole cloud complex there.
Oh yeah, I think you can even see some secondary reflection into the leading edge of this part of the molecular cloud here.
Oh.
Undoubtedly, there's a molecular cloud there. Yeah, let's try something. Let's go. Okay, that star is 1132 light years away, and LDN 1622 is looks like, is that 10,000? It looks like it might be 16,310 light years away, according to this. So that would put this star as a foreground object here, not the one illuminated.
1650.
Okay.
But yeah, still, I mean, that'd be a foreground object.
Yep. Let's see if we can color correct this again here. Oh yeah, see, the color correction shows the extent of the red nebulous detail, and you can see this is part of a large dark molecular cloud complex. This is beautiful here. All right, well, this is 36. We're going to save this now.
I think the red at the farthest right, bottom right, that's actually
Might
part
be
of the Barnard's Loop.
Barnard's Loop. It might be. If we go back here and look, we can see that Barnard's Loop is a remnant of an ancient supernova, guys, which is what you're seeing here. Okay, it's a remnant of an ancient supernova. And what Daryl is suggesting is that maybe some of this red here could be a remnant of this Barnard's Loop that's in our shot. And it's possible that some of this is. This looks soft and cuddly, doesn't it? It's just so nice. Yet it's unimaginably terrifying to be here, I'm sure. Okay, let's save this, and let's save it exactly as seen. And we'll come out. This will be up on the server for you all to look at just by going to skytourlive.org up there, and you'll be able to see it yourself and take it down and examine it and play with it. And what we'll do is process these later, and to our Patreon subscribers, they'll get a chance to see these. We'll make them available to our Patreon subscribers.
Yeah. Izabela was posted on the server. Let me find it. There it is.
Okay. All right. So let's go back now. And let's now I'd like to I want to go to Witch Head. Actually. Huh?
Okay.
Yeah. And to go to the Witch Head means going to here. Cursi Jadruza. So we're going to head to that, and we're going to be at more than enough altitude to see it nicely. Let's bring the telescope back. Here we are. And let's come back here.
Probably going to take a few shots to get it all on the field with the new camera.
Correct. I just want to do the top part right here. So what I'll
The
do
two.
is, I'm just going to go and just send us to that location of the field. Okay. Okay. And that's where we should be. There it is. You can see part of it there. All right. So I may have to go up a little higher. I think, maybe. There we are.
Renee, per your question earlier, this is live or nearly live right now. 1 second exposures.
Oh yeah, it's true. All right, so Cursa is this star here. So what I'll do is go to Cursa. All right, and we're going to bring our telescope with Cursa into the middle, bring the view in. So let's bring up our reticle and let's center up Cursa. All right, here we go. Okay. Okay, here we are. We're going to center that up. All right, here we are. That's good enough. Inside the inner circle. All right, so we come here now. And what we're going to do is center that. And you'll see where it says STLS, thinks it's down there. It's off a little bit. So we're just going to synchronize and bring that up to here. And now we are in sync. So now what I can do is take us down specifically to a specific spot. And we're going to go to here. So I have an orange star here, that star there, and that star there. Okay, so we're going to do this. And now we'll just say, go to that spot in the sky.
Do you see the witch's head in the stellarium, folks? The face is upside down. She's facing to the left.
Yes, she is.
That's her chin and her mouth. In the
what does she
present,
think she's doing?
Huh?
Yeah, what does she think she's doing? Okay. Now coming back here. So you got one star, that's this star, two stars, and then another orange star. So we should have 1, 2, and then the third orange star. So right now our view right here is dominated by that chin, that area of the witch's head. And we're gonna do a 35-second shot here. And we're guiding already, so go. And this is a really extensive nebula. And let's get out of that and go into our live stack. Get rid of the last one if it's still there. Yeah, the Boogeyman. That was another beauty. That's up on the server now for your consumption. And if our winds have died down, I should be able to bring this number down. Yeah, they have, see? Okay, so let's come in here and move out a little bit. There it is. Look at that. There's the top. There's our stars we saw. See that? And let's bring this down so we don't have to worry about any errant images. So 7.55. We should be fine in there. Alright, so now we're going to color correct this. Give us more of a black background with the proper color of this nebula. And this will be kind of a greenish blue as it appear to your eye. Okay, Calabo says, can I tell how many times the share button? No, I can't. I don't know how to do that. Calabos, I don't know how to tell how many times the share button was pressed. Okay. Here we go. And we can undock this again so we can get a full shot here. Very nice. So I hope you folks are having a good time tonight. I know I'm having a good time. Anytime I get to run this equipment, it's just amazingly fun to take you guys on a ride through the universe. So you might say, where is this? The Witch's Head Nebula is actually right next to Rigel, the lower right star in Orion right here. And you'll see the Witch's Head Nebula here. That's actually kind of where we are. We're in the Witch's Head Nebula. And it's designated as a reflection nebula. All right, so, but the light that it's reflecting is the light from Rigel, several light years away. Okay, Rigel is a very, very bright star. Rigel, like I said, lower right star in Orion. Very hot, okay? It's a star that's a star that's almost a star. It's a B8. So you have O, B, A, F, G, K, M. From hottest and bluest to coolest and reddest. So this is a B8 type star. So it's not a hot O that only lives a few million years. This one lives a little bit longer. It's a B8. However,
is what's illuminating the Witch Head, right?
The Rigel. Rigel is, yeah. However, Rigel is a B8 1A, meaning that it's a 1A with emission lines, so it has an E next to that. But a B8 star means that it's kind of a bluish star, but it's a 1A star, meaning it's a supergiant blue star. All right, so this is a star that is very massive. This is a star that will end its life as a supernova. And so who knows when that'll be. We can only predict. We can't actually say for sure. Same thing with Betelgeuse at the opposite end of Orion. So we're down here right now in Orion photographing that. But way up here on the upper left, we have Betelgeuse. Now, Betelgeuse is actually closer to us than any of these other stars. Okay. It's like about most like 750 light years. I've seen 550 light years. But it's a red supergiant that's on its way to a supernova explosion. We thought it might have been closer a couple years ago when it started to dim. Okay, so let's come back here. This is the Orion Nebula. We're going to make that our next stop. Okay, so let's go to let's center on our telescope's view. Yep, and let's go see now what we got. Look at that. There's 9 stacked. Looks really good. 1 second. Hey, Hunter. Good, how are you? My son just got home from work. It's 12:30. Yeah?
Eric asked a couple of minutes ago, is that a red dwarf middle bottom or a red galaxy?
This guy?
Yeah.
Well, it's certainly a star. And it may or may not be a red dwarf. It's most likely not. It's probably likely a supergiant, a red supergiant, but we can tell. Let's go in here. This is that star. Let's see what we got. Let's see if it's going to be listed. Yes, it's a giant. It's a K3/4 3, Roman numeral 3. So that's a giant star. Yep. A star like that's going to be a lot more massive than the sun. If you put it where the sun is, it might go all the way out to Venus's orbit, maybe a little less. All right. All right, so we've got 12 images stacked here. Let's go back, and there's a few other places that I know. Yeah, there's a lot more to see in this, but we're not going to do that all tonight.
If you see that, folks, if you can turn that around, if you remember the Wicked Witch of the West and the Wizard of Oz, the witch's head here looks a whole lot like her.
Yeah, it's upside down.
Oh, yeah. Imagine the Wicked Witch of the West standing on her head.
Mm-hmm.
She got the chin, she got the nose.
Yeah.
Shane, this is true.
Shane D45 says, I've read a few articles that Betelgeuse might have already exploded. Yeah, and once the light train reaches us, it'll reach us too. But if it exploded 749 years ago in 11 months, then that'll be here in just a few weeks or a month, right? So it'll take it that time to get here. Sorry about my voice.
What were you gonna do next?
I was going to look and see. Let's see here. I was thinking of just, showing people this region again and pointing out the geostationary satellites versus the non stuff. And because this is just beautiful to look at, and with higher gain, it'd be interesting to see what we can pull out. But we can do that real quick.
They were asking earlier about. Somebody said the nebula below Orion's belt, so I assume that's what they meant.
Yeah, we'll check it out.
That or the horse head.
Mm-hmm. Yeah, no, we'll do the horse head tonight. All right, let's do a color correction here. All right, that's a process. Let's color correct. There we go. Look at that. Look at that little filament right there. That's pretty. Look at that. Wow. That's nice. This is nice. 17 stacked. Let's increase the contrast. Okay. Now you can see the reflection nebula color of more blue here. This is pretty cool. Nice. Very nice. Renee Cruz, horseman head of the apocalypse. Hey Ronald, how you doing? Okay, Ronald, I have your Andromeda and double cluster shots for you. I will do a wheat transfer hopefully tomorrow. Yeah, what Calibos said. If you like what you see, guys, consider joining our Patreon. I mean, we'd love to actually be able to do this, full time. It's what we want to do. And if we have the ability to pay for the internet out there all the time and pay for other things, development of the new building, then we can, And so far, we have a few Patreon members that are really doing the lion's share. They're doing great, But please consider it. If you where our Patreon is, you can go to SkyTour Live, and in the upper right-hand side, you can see the Patreon page. On the upper left-hand side, you'll see this. You'll see SkyTour live stream. But join us. We'd love to have you. And it's fine to have you here too. Obviously, we're not trying to change things, but it's really good. Our Patreon list consists of John P, Izabela M, Ollie B, Chief McCyber, Vera C, Ronald T, Martin W, Raymond B, Cindy M, Susan W, Diane H, JSCO 77, Tiffany Echo, and now James Hyatt. I'm going to add him to the list. James Hyatt is in the chat. So that's all good. Okay, 21 stacked. We'll stop there. And let's... we're going to call this one the Witch's Head. I think I spelled witches wrong, but that's okay. I'll correct it in post. Okay, so we'll save it. Save it exactly as seen. There we go.
Mark, excuse me, please.
Sure. Okay. Okay, now, I'm sure you're all wanting to see the beautiful Orion Nebula. And that will make me do that next. No problem, James Hyatt. Thank you. Are you kidding me? Okay, so let's go back to our 1 second. Find your image. This is a 1 second shot, right? So every second, this updates and shows us what we're looking at. So you can actually see it update if you stare at the screen. Okay. Now, the other thing I wanted to tell you guys was that I've continued to work on the AllSky Camera, and the new AllSky Camera is finished, and the performance is exceptional. It's behind me right now on the table, capturing shots of everything I'm doing tonight. So here's what you'll soon have. You'll have and I'm going to make it for the website too. You're going to be able to see what's going on out at the observatory, hopefully 24/7. And we'll have files available to show you time lapses of the whole previous night. So you literally sit there with this fisheye watching the whole sky. You'll see meteors and things like that, satellites. It's really exciting. And then what you'll also see are the changes of the seasons through this. As the night wears on, you'll see the beautiful skies changing as the stars rotate through. It's really nice. Okay, here is Orion's Nebula. Now, let me stare at the screen for a minute, and already I've identified a geosynchronous satellite. They might say, well, how can you do that? Because it's right there. See that little satellite moving very slowly through the picture? See that? Okay. It's okay, here we go. It's catching up. Right there. That's a geosynchronous satellite. And as the seconds tick by, you'll say, well, wait a minute. They're supposed to be at one spot over the Earth. It is. It's over one spot on the Earth. We're the ones that are moving. We're moving by following the stars as they advance to the west as the Earth rotates. You're literally watching the rotation of the Earth. Okay, that's what you're seeing here. So, if we look at the screen here, let's wait a moment. I want to capture one of these because I want to show you how this works. Over here, I'll point this out. See this button over here? It says track. See that up there? This is showing us that we're tracking what's going on, and we're tracking the stars. But if you turn it off, then it'll just be staring out from the Earth without tracking the stars. So, theoretically, if we look at our geosynchronous satellite, then we might see that as we're staring at the Orion Nebula here, the geosynchronous satellite's moving because we're rotating out from underneath it as we're following the stars. But if we stop following the stars, then the geosynchronous satellite should move, or should stay perfectly still. And I'm waiting for a geosync bird to show up so I can do that. Oh, there it is. There's one right there. See that? Watch. I'm going to turn off track, and you'll see it very clearly. Alright, so I turned off tracking. There we go. And look where my arrow's pointing. Stars are moving, but that one isn't. You know why? Because that's the one that's over the same spot on the Earth, and that's the telescope trying to correct it because they've got the guider running. So you saw what happens, right? So if I hit track again, now it's going to follow and track properly. There we go. So now we're going to just push up north just a little bit because Orion Nebula is here. And then this one here is the Running Man Nebula. This is just a beautiful section of the sky. Oh, yeah. Just go one more click up, and then we're going to do a nice long shot so you can see all of the region. This is effectively a blister of an emission nebula off of a gigantic black molecular cloud of dust and gas here. That's the Orion Nebula, and you can see a faint hint of like a dark thing here. You'll see very clearly what that is in just a moment. So let's do this. Let's say this will be 35 seconds. All right. And let's go do it. And you'll see the rest of the geosynchronous satellites in here that you didn't know were there. Okay, let's take this and let's redock this for now. And let's clear this last one. And come out of our last one here. And our image, our star size should be small. So let's see if it works. I'll leave it here. I have it at 7.55. Let's see if that works. We're about to find out right now. Nope, 9.24. All right, so let's increase it just to that threshold. All right, and see what we get. We might get slightly oblate stars at this point, but we'll find out. Very nice. Okay, let's see the next one. Okay, not quite. I could run it at a slightly shorter exposure. I could do 30 seconds. But 30 to 35 may not make such a big difference. Alright. 3 seconds. 2, 1, 0. Hey, there we go. Look at that. Wow. Again. And there's one of the geosynchronous satellites right there. Look at all that stuff. I mean, that is just a lot of dust. Is that not amazing? That is just something. All right, let's go back to our histogram and color correct it. There we go, color corrected. And this processing is actually pretty good. Mike Townsend, yeah, no kidding, huh? There's so much stuff here, Mike. There's so much incredible dust in here. This is all part of the Orion Molecular Cloud Complex, the OMCC. And this is what is all surrounding the constellation of Orion. It's all here. You might have remembered I talked about emission nebula and reflection nebula. The reflection nebula are blue, the emission nebula are that red. But if you have an emission nebula that's inside a blue nebula, the light that actually gets to your eye is affected by the blue light that is mixed in, and thus it'll end up looking magenta. And that's why this looks magenta and not like this hydrogen alpha or this hydrogen that's been ionized. Look, that's also ionized hydrogen, but it's a different color because we're seeing it through blue light that's already in this nebula. We're going to let a few of these come in so that we can actually get get a good view of this. I have just as many that came in as that were ignored. So I might make some adjustments, but I like my round stars, but I might be able to just kind of move that threshold up just a little. But isn't that something else? Look at this beautiful line of dust here. Oh, very, very pretty. Look at that. It looks like clouds in the sky. And what that actually tells you is that the way the universe works is according to physical principles that govern other types of anomalies, like clouds in our sky. Look, here's more geosynchronous satellites. See them? 1, 2, 3. I can get rid of those in post. Boy, this is something. Wow. Eagle's interesting question, interesting comment from Eric's Automotive Diagnostics and Repair. He says, Eagles can see far away, 5 times better than humans. Can you imagine what the sky looks like for them at night? I would be interested to know if they could anatomically use the lens of an eagle's eye and see. Now, eagle's eyes are not as large as human eyes, so the light gathering power of the eagle's eye is less than ours. What they have, though, going for them is that they have a capability to see far away because they can actually magnify their distance. It's sort of like Steve Austin. They can magnify within their eye to see a little bit farther away, which is kind of cool. So if they ever chose to look up, I don't know what they would see. But I don't know any stargazing eagles, but I'd love to.
If you ever see an owl's eyes,
Yeah,
they have, they're not round. I mean, they're quite, what's the word I'm looking for? Almost cylindrical and round on the ends. They have more focal length.
yeah.
So like eagles, I guess, they see a little sharper, little longer, a little farther.
Yeah. See, guys, when you look at this object here, okay, one of the things to keep in mind is that this whole object is not just the Orion Nebula anymore, is it? It's the Orion Nebula, and this is all part of that whole area. And this is also intricately related to and part of this whole area. So you see, we're watching and seeing the universe live in real time. We're actually seeing how interrelated everything is in the universe. Look at this overlaying material here. That stuff is actually in front, and the bright nebula is behind it, and this is actually silhouetting it. So that's what we're seeing there. If we zoom in on that, you'll see very clearly. Look at that, all live in real time. Check that out. That's really pretty, Daryl. Holy cow. Yep. Looks like a painting, doesn't it? Now, one thing I can also do here, and I'll just bring this up for a moment. Okay, and like if we want to see more details, there's a couple things we can do. This particular camera allows us to have many levels of definition. So it's actually a very high definition camera, but we also have the ability to literally dive into the nebula by bringing this stuff down. You can get down to a certain point, right? So you can see other details in the nebula. Like, look at this beautiful coloration, right? That's all available to us because we have many levels of dynamic range, okay, that we're seeing here. Now, what's also interesting is if you look at like this right here, okay, this object right here, you see this little tongue of green stuff. That's actually oxygen, doubly ionized oxygen. We talked about the hydrogen, singly ionized hydrogen. But this stuff, this green stuff, is not this blue stuff. This green stuff is oxygen. Oxygen atoms that have been doubly ionized glow green. And so that's what we're seeing here. Now, what I was talking about before was if you look at this object right here, you'll notice something fascinating, and that is that you can see the green passing over this hydrogen area, but you can see the hydrogen showing through it. It's a lower density area. Another area where that's even more obvious is right here. Let me zoom in on that and show you. Okay, so here is an oxygen, ionized oxygen area, and it's lower density than this hydrogen ionized area, and so you can actually see through it like a veil and see the hydrogen behind it. Isn't that incredible?
I have a question.
Sure.
When you see colorful meteors in the night sky, you'll often see the tails as green. I have seen that described as oxygen. Is that doubly ionized oxygen? I have seen other colors also ascribed to oxygen in auroras, for instance, red, yet it's oxygen. I'm sure those are just different ionization states. Am I way off base here?
Nope, not at all. Not at all. And the different oxidation state or different ionization states do show different colors. When you see certain auroras, okay, you see green, that could be oxygen. You can see red, that could be oxygen as well. And you think, well, what's going on there? It depends at the altitude of these. But you also have to keep in mind that some of these colors, right, are related to the chemical composition of the meteor that's burning up in the atmosphere too. Okay, so that that could be, for instance, related to the element that it's made up of, like sodium. Right? If there's sodium, you'll see yellow. Right? Well, we have also sky glow from sodium atoms in our atmosphere, and that's yellow. We have green, we have red, and that's from the all day long the atoms are absorbing energy, and then at night they give off the energy in the form of a soft light, and that becomes the sky glow. And we see green, we see red, again from nitrogen and oxygen. So predominantly, because that's mostly what our atmosphere is made of, right? So those colors then are definitely related to the compounds that make them up. You know? Yeah. And nitrogen and oxygen, you'll see red. You know? You'll see green from oxygen. You'll see green from other elements too as well. I think you can see green from iron as well. We know that copper burns green, but that's not what we're seeing generally. But one of my professors that was one of my professors when I was in college, he's retired now, when I was getting my degree in astronomy, he's a meteor specialist now. That's kind of funny because he was never interested in that before. And then all of a sudden, he's interested in meteors. Look at this photo. I mean, talk about a messy spot in space, huh? Jeez. Let's get rid of the telescope for now and just go full screen on this, shall we? I mean, this is too beautiful to just let it go on its own without looking at it. Look at this. Wow. Ay, ay, ay. I mean, you can see this material going all the way down. All the way down. And remember, the universe is in 3D, so we don't know if it's like this or like this or like that. I mean, I'm going to guess that this is farther from the Orion Nebula. And this is farthest of all. That's my guess. I actually don't know the answer to that. Our geosynchronous satellites are going through making faint trails, but you'll notice that they're getting wiped out. They're getting wiped out because they exist for only that one frame, and then the next frame has some on it. So over time, the blackness of space starts to come in, and over it fills us in. Geez, that's beautiful. I think it's a beautiful object to end on tonight, don't you?
Sure. Always one of my favorites.
Well, it's just such a complicated location.
Oh, yeah.
Just incredible. Wow.
Ronald, this image is 3 moons across, 2 moons top to bottom, 1.5 degrees by 1 degree. No, not even close.
Well, tell people what you're answering so they know.
Ronald asked how many degrees across. First he was asking how big the Orion Nebula is, and I looked it up and told him it was 30 to 40 light years across, and then he goes, how many degrees? And I jokingly said, well, if you use math to do that.
It's about 30 arc seconds. 30 minutes, I mean.
Say that again?
The overall nebula is about 30 minutes for this area right here.
About the size of the moon.
Yeah.
Yeah. I mean, degrees, Ronald, there's 360 degrees in a circle. If you look at the visible sky from horizon to horizon, that's 180 degrees, or halfway across, halfway around. Then you just keep dividing it smaller than smaller.
Yep.
45 degrees is halfway between the horizon and straight up. Straight up is 90 degrees. 10 degrees is about the width of your hand at arm's length.
Wow. Beautiful.
The sun and moon are about 1/2 degree across, or 1/2 degree across.
Mm-hmm.
As Marc said, Orion Nebula itself is about 1/2 degree across. Where you factor distance into that, I mean, for us to look at an object here 30 or 40 light years across, for it to be 1/2 degree in size in the sky, well, that's what the nebula being about 1,500 light years away would look like. 40 degrees across, or 40 light years would look like about the size of the moon. This is all over the thumb approximation.
But good enough. Not a bad job. So we color correct for the right colors in here, but I also wanted to mention that there's other color corrections we could do. Like this one is biased into the blue. Okay, that is not the kind of thing that I would do. And so I would probably do this And we can also use what's called a stretch mode. And that stretch mode, new, okay, it's new. So we could do this. We could drop this down like this. All right. And it helps us to see the data a little bit more crisply. Or we could bring it up and add way more data into it until it looked like a real mess. Okay. Notice we see noise now when we do that. Okay. But you can see the extent from this of all this dust in here in this molecular cloud complex. So I think that it's best at level 4. There we are. Look at that. So let's go and bring our docked imagery back. We've done 24 images. We're going to do one more. It's almost done. But this is measure 42, the Orion Nebula. This is measure 43. And then up here we have the Running Man Nebula. There we go. Boom. And we wanted to get that last one, but we ended up just over the threshold. So I'll wait it out. Not going to do it. All right, here we go. Michael Hedrick, hey, sorry I didn't say hi earlier.
He just got here.
Oh, he did? Okay. Very good. Yeah, you're still on. Yeah, this is the last object, though. But, hey, what a way to go, Michael. Check it out. You know, here, let me just drop this away for you so you can see. Look at that. That's the Orion Nebula and the Running Man Nebula up here. And this beautiful dusty region is all part of the Orion Molecular Cloud Complex. And it's in this dark where life comes from. We come from the dark. I've said that before. That's beautiful. Look, I'm in the nebula. Ooh. That's really pretty. Okay.
When we look at the nebula and talk about Messier 42,
yeah,
we're talking about the lower part.
Yeah, not this.
No, that's M43 right there.
Yeah, that's De Moran's nebula as well. They have several names. Okay, let's save this. We'll go 27 because it's almost there. There it comes in. Yep, it did. And there we go, and we'll save it just like we see it. Wow. Fantastimo. Oh, man. Yeah, this is something. Okay. Orion is almost up right here, and so that's the best view. And I wonder... okay. One more. Just one more. We're gonna try it.
To say that.
I know. Just one more. That's my name. It's my nickname. Just one more, D'Antonio.
You were looking at above the back of Canis Major. It looked like.
Yeah.
Thor's helmet.
No.
Oh. Okay.
Not doing Thor. Thor's a little more south. I'm going to do something a little different.
Wait, Thor's helmet is in Apophis?
Yeah, it's further to the east.
Okay, right.
It's not quite ready for prime time yet.
Yeah.
Okay, let's do this here. And let's do that. Okay, so this will be up on our server in no time. Except that it's going to show up on the Witch's Head Nebula because I forgot to change it. I'll change it later. Okay. All right. What I could do, though, just to be safe. Oh, stop that. I'll just do this. Yeah. Okay. Now we'll save it.
It didn't like whatever you just did.
Yeah, I know. I can fix all that. Not a problem. If you notice, it saved it in the Orion Nebula region, so we're good. Okay. It's already uploading them, see, so it doesn't matter. Okay. Good. Alright, so now what we'll do is let's redock this. Let's bring back the telescope. There we go. And it's like you just don't want to leave this region because it's so beautiful. You know, what I'd like to do is compare it really deeply to the same photos we've taken of it over time to see if we can even see the slightest difference. I bet you there are differences, they're just not as pronounced. Okay. Like might be new stars or something like that. Alright, so and before we go, let me just do this. Go back to 1 second. And then zoom in down here just to show you what's powering the whole Orion Nebula region. It's these 4 stars. These are 4 hot stars. There's more than this in here that are helping. But these are the 4 primary stars. They're called the Trapezium within the Orion Nebula. Notice the green doubly ionized oxygen in here. Okay. And now that, just one more, I promise. Let's give that a shot. We're going to try it now. Let's see if we can get to it.
Oh, the Seagull.
Yeah, let's see if we can get to it. I think we can get to it. I think the Seagull is open and available. There it is. There's the head of the Seagull right there. Okay, let's go a little east to get the upper wing. Okay. I went a little too far. Go back a little west. Okay. This will be the Seagull Nebula. A lot of people
when
love
Marc
this
showed
nebula.
you the Trapezium stars at the center of the Orion Nebula a moment ago, that's what I was talking about with dynamic range in chat a little while ago.
Yeah.
The
Okay.
human eye, when you look at the Orion Nebula in a telescope, you can clearly see the trapezium as the bright part and the surrounding nebula as the varying dim parts at the same time, just because of the dynamic range.
Right.
That's something the human eye will do that a camera can't do.
Yeah. That's because the camera accumulates data and the human eye throws it away.
Oh.
Okay, let's get rid of that.
I know you said that early tonight. I've heard that actually the human eye can integrate to about 1/4 second exposure.
Well, okay, but you know, in terms of acting like a camera, it really can't.
Right.
Because none of it's actually saved.
Right.
There's the Seagull. Look at that. This is the first time we've seen the Seagull with this camera. I think we should probably right away go check our filters, see where we got to be. 7.13. So we'll just bring us down to just above that. So keep our stars in that region. Okay. And let's... Good. Now, last time on with the other camera, we could see the entire seagull, but we're looking at it now, and we're using more pixels to see a more magnified view. Okay, so let's go over here, and let's ride this up the curve to just before the peak. Give us a good dark view here. Move this down. That's pretty. I also want to actually come in here and color correct. Yeah, there we go. That's something. Beautiful seagull. The seagull has this really interesting black line through it. Are you able to see the seagull? There are some that say this is the eye of the seagull. This is the beak of the seagull right here. And these are his wings, and he's kind of looking to the right. If you do that, it kind of looks like a alien embryo or something. I don't know. It could be the Piranha Nebula, too. That looks like a piranha's face, eyes, and mouth.
I remember seeing this on the old camera. Do I see a parrot more than a seagull?
Yeah, we talked about that. Yeah, it kind of does look like a parrot, doesn't it? It sure does. Kind of looks like a parrot. You're absolutely right.
I mean, it's sort of bird-like. I don't know about a seagull so much. Parrot's got the bigger, blockier beak to it. Maybe that's what I see at the top right there.
Yeah, see, this is the peak right here. This comes over the top. The eye is down here. There's the beak, and there's the gap, and here's the lower jaw, and there's the big old parrot's beak. Look, he even has feather tufts. That's pretty nice. How many do we got here? We have 8 stacked. Do we lose any? No. Okay, so whatever wind we had, it's gone now. So let's get that out of there. That's not bad. You'll notice again, as always, we see there is a combination of red nebula and blue nebula. See? We're seeing reflection nebula and we're seeing emission nebula. And that reflection nebula again is the light being scattered by the stars in the area. Okay, the light being scattered by the dust in the area from the stars, and that's what we're seeing here. And it's scattering the high frequency light, which is the blue part of the spectrum. Again, same reason we have a blue sky. Same exact reason. Rayleigh scattering in space. Kind of like pigs in space, but nothing like it. Michael Hedrick says those wisps are beautiful, enchanting. I think he might have been. Were you talking about the Orion Nebula shot? That was also enchanting. Hello, Judy M. I know you're late, but that's okay. I'm glad you're here. You don't have to worry about the lateness. You can always watch it again. Oh, Judy was baking bread. Man, did you bring enough for the whole class? That's cool. Wow. This is the first time we've seen the seagull with this camera.
Mm-hmm.
is definitely, we pick up more details than we did with the other camera, that's for sure.
Looks like another one. You'd have to mosaic it.
Yeah, right.
That's the whole thing.
Get the top and get the bottom. Yeah, keep in mind with this particular telescope and this camera, the distance from here to here, okay, is 1.5 degrees. The distance from here to here is just 1 degree. So 2 moons, okay, and 3 moons across. And that's it. Somebody's having a field day on the heart icon.
Yeah, I know.
Wow. Yeah, this is something else, man. And what's interesting is everything we see in this telescope, these are all transient items. They're going to go away. They're going to change. And at this point, we're not able to determine when, for instance, this nebula will cease to glow anymore. It's glowing because of ultraviolet radiation from nearby stars that are young. And when those stars are gone, when they move out of the area, well then this gas cloud isn't going anywhere. This gas cloud is still going to be doing its own orbit around the galaxy. And as the stars pass through it, potentially that cause it to glow, as they move past, they will get out of range of the ionization potential that would make the hydrogen gas glow, and then it'll just slowly fade away. In fact, we're going to be watching that happen right now and not know it. So, but you never know. I'm still stunned by that Orion image. That was really pretty. Wow. Amazing. Let's zoom in here. And once you see a parrot, you can't unsee it. Beautiful, very detailed and intricate area here. This is a lighter area, a darker area. Absolutely incredible. We have 20 stacked already, so what I'll do, since this was just our one more, let's come back here and let's redock this here. All right, and we'll do 21 shots. There we go. We have it named Seagull Nebula. Boy, this telescope really has been getting quite a workout over the last couple of years. Thanks for putting up that link, Daryl. Oh, name of the crater we caught live. No, actually, it was a relatively small crater compared to other ones around it. But what struck it was something about 2 feet across. But it struck it at many kilometers per second. So when it struck the moon at that high speed, you had this instant conversion of the kinetic energy, the energy of motion, being converted into thermal energy. Because energy cannot be created or destroyed, the motion, 1/2 mv squared, 1/2 the mass times the velocity squared, is the energy that it has. And that energy was then, it had to go somewhere when that meteor came to a dead stop upon striking the moon. And the place it went was into thermal energy. And I don't know the name of that meteor. I'll find out, though.
About the impact we saw during the lunar eclipse.
Yeah. I know there's a lunar reconnaissance orbiter that took some photos of the crater.
Oh, really?
Yeah.
Hmm. They would have expressed the impact in terms of, they usually do it in TNT, pounds or tons or kilotons or whatever. Wasn't big enough for kilotons.
I don't remember. I mean, it came in at like, was it 10,000, 20,000 kilometers per hour?
I don't remember. I'm not sure I ever did hear.
Okay.
Michael Hedrick wants to know if we can zoom in to the right of the bright central star.
Like this right here? Oh, yeah.
I suspect so.
Okay, Michael, sure we can.
Cloud area.
And by the way, guys, if you do have something interesting you want to see, you are in control. You can call us. You can write us in the chat here and tell us what you want to see. All right, so here we go, Michael. Let's just pull in there. Look at that beautiful set of wisps coming off the top there and over here.
Oh.
That's really pretty. Really pretty.
I think that's what you called the feathers on the back of the parrot's head.
Yeah, I know, right? With the crown feathers. That's really cool. It is just amazing. I'm glad you guys really like this stuff because I'm not going away. I'll be doing this for a long time. You know? After all, I've told you this before, I knew I was going to become a professional astronomer when I was 9 years old. So I kind of lived a sort of a boring life because I never changed that. I stuck with that, and that's what I did. Kind of weird, isn't it? Usually people change their careers several times. When astronomy didn't pay, I started out life as a professional astronomer. And when it didn't pay well, I got into computer science, which is a logical offshoot. And then I ended up being very dedicated to getting back to my astronomy. And it's a good thing I did all the programming because what you see here, all right, I've written the program to control the observatory, and I learned how to interface hardware into programming so I could write programs to control hardware. Not hard. I used Arduinos, which are little microcontrollers, and managed to figure out how to do things like open the garage door, which is actually what this is. It's a horizontal garage door, and the garage door opener is right there on the wall. You can see it right there. And that it's a 1.5 horsepower garage door opener, and I just run it horizontally, so it's under no strain. It doesn't have to go back up a hill like a regular garage door to open with the springs, and so it's really perfect.
Maybe I'll show you something I built sometime.
All right.
I used a programmable logic controller.
Okay.
It was just an old PLC.
Yeah.
We had in the junk pile. I built the whole thing out of junk, basically. I think I've shown it to you before.
Maybe, maybe not.
It was a tape applicator.
Okay. Oh, yes, you did.
Time.
You did.
Yeah.
You absolutely did. I remember that.
Some of the time, not too much.
Okay. I'm gonna just show folks. I'm gonna show you guys the. I'm gonna show you the AllSky camera real quick and what it's doing. I have it testing on the other side of the room. Let me actually bring this back up. Bring that over here. Sorry, I know Daryl is looking kind of wacky to you right now.
What?
I'm sure the screen's looking. Is the screen looking a little wacky to you, or do you see it okay?
I think it's okay.
Okay, good. All right.
I'm not sure what you're doing.
I know you don't because I'm unable to share this the way I want to. Yeah. Okay, hold on. All right, this will work. Let's do this. Left, right screen. Browser. Just a second. Just a second. Maybe this? Yes. Okay. Okay. This is an example of the AllSky camera, and it's right now it's running behind me here in the ship office. Okay, and you can see, you can read everything. This is a very high res camera, full color. So this gives us the opportunity to see the night sky. It will be. It's already focused for the night sky like never before. And we have all kinds of things we can do in here. There's all kinds of settings that we can set for this. So this gives us a lot of options. And then we have images. And it takes images by day, and it makes time lapses. Okay. So
surely there is a lens on the front of the camera.
Well, there's a lens, that's correct, and then I have a dome over the camera.
Yeah.
Yeah. So there you go. So this is what it makes. That's like the time lapse. It does that by itself. And then it does these other things called kilograms. And what are these? Well, what they are is they are separated by hours, 18, 19, 20, 21, right? And it gives you the date for on 1/10/2024 from 6 p.m. to 6 a.m. It shows the quality of the night sky. So what we're seeing is in this one, it looked like this, and this looked like that. Now, these would normally just be star bars. But if clouds came through, you might see some clouds here or there. Okay, this is a test shot. So obviously, each of these is a separate, a separate dragged out image of the one, that 1 hour. So that's what kilograms do. They actually allow you to see the night at a glance. Okay, and so we also have the actual images and all the images. Okay, so here's all the images taken, for us so far. Those are all going to fill in over time here. So, like, one image looks like, like it'll come in and I'll show you. So I built the camera using a ZWO ASI 678 camera, and then a Raspberry Pi running Linux. And so anyway, that was really cool. So let's just get back to our thing. Oh, look at that. Wow. And that Raspberry Pi is the reason. I'll answer you in a second, Mike. That Raspberry Pi is the reason why we are able to do this so quickly. It's a full-blown computer, but it's that big, It's even smaller than my microcomputer. Not as fast as my microcomputer. The microcomputer is a little bigger, and that is as fast as the machine I'm on now. Actually, a little faster. But it doesn't have the graphics capability, so it couldn't support all this thing that's on my screen right now that you can't see. But it's pretty close. All right, Mark. Michael says, Mark, have you caught meteors on the time lapse? Out there in the field, yes. Let's start up the night AllSky Cam here. All right, and we'll take an image. Okay, and we'll say one acquisition. And this is the image of the current AllSky Cam. Compare this one to the one that is out there now and I'm showing you. Look at that. There's Orion. There's the winter Milky Way. There's bird poop. Can't avoid that. That is east. That's toward the city of Phoenix, 80 miles away. The camera's so sensitive it can see this stuff. But look how dark it is everywhere else. It's really dark here. So anyway, this is our current AllSky Cam. And it's really not it's not that good. I hate to say it. So you can't really zoom in on this, really, you know. And Pleiades are just a white smudge. On this new AllSky Cam that I made, you can actually see all of the stars in the Pleiades. It's really, really nice. All right. So there we go. And let's see where we are now in here. Now that we've done this. Okay, great. We're going to save this now. See, for the extra one, we did 50 images. That's incredibly cool. All right.
Don't forget to name it.
Oh, it's already named. Seagull Nebula. I did that before. But thank you, because I did forget one of them. In fact, before I go to bed, after I close up everything, I'm going to go out and rename everything the way I have to. So there you go, folks. Look at that, huh? There's the seagull. So you'll see a lot more detail in here when we process this. For the Patreon subscribers, you'll see all the detail. Really nice. Yeah. So I goes to sleep now. I hope you guys enjoyed this. I want to thank you guys for coming out. I'll do one more save. And thank you for being here with us. And we'll be back probably a day after tomorrow if it's going to be clear. Or for any major events that occur, we'll be there. So you guys have a good night, and we will talk to you later. And remember, if you go outside, just keep looking up, man. Keep looking up. So I hope you guys have a good evening, and we'll see you. All right? Thanks
Good
for
night,
coming.
everybody.
See you guys.
Good night.